Yeah, okay. Hey everybody, we're live and in stereo. So today I'm gonna go over a paper, ATP guest paper type of thing. But really, ATP is one of the easiest papers, and like I've made a lot of videos on ATP as well, and I've said this over and over again. It's a very, it's this the examiner has to say within the boundaries of the syllabus, and it's a very predictable paper, and even the examiner has allocated certain boundaries. So remember that question number two will either be for titration, it'll either be for change for rate of reaction or temperature change, or it's going to be some sort of a graphical experiment. So it's going to involve graphs of some sort, or either it's going to be titration, right? Then you also need to understand that question number three will always be salt analysis. He's going to talk about salts and identification of ions, cations, anions, tests for cations and gases and whatnot. So that is largely what question number three is going to revolve around. And then question number four has multiple aspects to it. So it can either be a logical experiment requiring you to carefully read the question and devise and plan an experiment accordingly. All the information would be given to you in the question, or it's going to be salt preparation. So it's either solubilities or salt preparation. He'll ask you to separate certain mixtures from each other, or chromatography and all the other separation techniques are usually inclusive of identification of apparatus, are usually tested in question number one. Other than that, salt preparation is highly likely to be tested in question number four. So I'll go over all the experiments with you guys one by one, and I've compiled a question or two for from each of the experiment. Although I've made detailed videos on titration as well as salt analysis, so you could check that out on YouTube by the name Carboxyl, at Carboxyl, right? So if you guys want to go over titration experiments in detail or salt analysis in detail, you guys can check the YouTube channel out for that. Other than that, I'm going to be covering titration experiments here, a question or two from that, and the thought process behind it. I'll be covering rate of reaction experiments here, the tricky ones, obviously, and obviously temperature change as well, right? So today our agenda is very simple, and then I'll also go over a couple of planning questions for you guys. Planning is very easy. It's just 6 marks question. The highest weightage for your questions are either question number threes, which are salt analysis or identification of cations and anions, or it's basically your question number two. Question four is largely for 6 marks only, and it's easy, very easy to secure those 6 marks, right? But we are going to go over them as well, right? For organic chemistry, I don't know, Yusra, they've never tested organic chemistry, but they can test fractional distillation of crude oil or whatnot, so you need to go about it. Taha, the separation techniques aren't uploaded, they are on the portal, and for the portal you could request Miss Noor. She caters to everything, right? Okay ji, chalo, let's start off. So the first question is for titration, right? That is largely gonna be question number two for you all, right? Now it says solution K is dilute sulfuric acid. Again, before I solve this question, I need you all to understand that titration is an experiment in which you use a known concentration, a solution for known concentration, in order to find out, a solution with unknown concentrations. You want to find out a solution's concentration which you don't know with the help of known concentration. And remember, it's a very simple experiment. It's a very easy experiment. The entire idea behind titration is that either the acid solution or the base solution, the concentration for that would be known to you. For example, I say, hey, I have HCl, or in this case H2SO4, and let's suppose concentration for which is known. Let's suppose it's 1 mole per dm cube, and after I perform the entire experiment, after I perform titration, what I'll end up with is volume for neutralization, right? The volume that was required to neutralize certain amount of alkali in the conical flask in this case, right? So the alkali which I have, let's suppose I use sodium hydroxide and I added 25 cm cube of sodium hydroxide. The entire idea behind titration is to figure out how much volume of acid, of known concentration of acid, was needed to neutralize this 25 cm cube of NaOH. And once you figure that out, let's suppose it's 20 cm cube, right? Let's suppose once you figure this out, you could use the volume of neutralization, the volume of acid that was is used up and the concentration of the acid and figure out the moles of the acid, N equals CV, right? And you're going to get the moles of hydrochloric acid. Now, why do we need the moles of hydrochloric acid? Because we can use the equation. What is the equation? The equation is given to us obviously in the exam, but you could also be required to make it. But for ATP, they give it to you. They give you the relationship between sulfuric acid and the alkali which they are reacting it with. So whatever equation you're given, you'll take the ratio between the two, and the moles that you figured out here for hydrochloric acid or sulfuric acid, whatever acid you were using, you would use that to figure out the moles of the alkali, right? And once you have the moles of the alkali and you have the volume, you already have it, that's 25 cm cube, you could once again use N equals CV to figure out the concentration of the alkali, because you have the volume is 25, but remember to convert it in decimeter cube if the units don't match, and you have the moles which you figured out through this. So the entire idea behind titration is to figure out the concentration of an unknown solution with the help of a known solution, right? And the entire experiment is carried out to find this volume of neutralization, because this volume along with the concentration which we know helps us figure out the moles. And once we figure out the moles, you could use the equation to find the moles of sodium hydroxide, and you could use that equation, and then again once you have the moles of sodium hydroxide, you already have the volume, you're going to figure out concentration as well. Now remember, it is not necessary that the entire experiment is from the perspective of the acid. It is also quite frequently possible that he gives you the concentration of the base and requires you, or the alkali, and requires you to calculate the concentration of the acid, right? So it could be also be reversed. So it's not necessary it's always going to be acid is going to be the starting point. The alkali can also be the starting point, and this is the core idea behind it. Now, one more thing that you all need to understand is that if I want to figure out the concentration, of two different alkalis, right? If I want to figure out the concentration of two different alkalis, I have 25 cm cube of alkali B here, and I have 25 cm cube of alkali A here, right? Let's suppose. So I have alkali A in one conical flask and alkali B in the other conical flask. Now, in one case, I know that I'm using hydrochloric acid. I'm just giving you guys a thought process behind it. We'll solve the question, don't worry about it, but I'm just giving you a thought process, right? So in one place, I have the same hydrochloric acid, which is 1 mole per dm cube, and I have the same hydrochloric acid, which is 1 mole per dm cube for the experiment B, right? Using alkali B. Now, my question to you guys is that what if I say that I performed the experiment, and in case number A, for alkali A, 20 cm cube of volume of neutralization was there, which means that 20 cm cube of hydrochloric acid was required to neutralize this. But for B, let's suppose 30 cm cube of hydrochloric acid was required to neutralize B. Which solution is more concentrated? Which alkali is more concentrated? Is alkali B more concentrated, or is alkali A more concentrated? If you guys still, mess this up, you guys can watch the video onto YouTube, but it is actually, in fact, alkali B. Now, you guys may be wondering, why is it alkali B? Because realize that this, for the same amount of both alkalis and the same concentration of both hydrochloric acid, for one alkali, 25 of A were completely finished only using 20 of hydrochloric acid. But on the right hand side, 25 of B, the same amount of B was neutralized or finished using 30 of hydrochloric acid. So realize that, in B case, more hydrochloric acid was needed to finish this off, which means B has a stronger power. You need more drops of hydrochloric acid to completely neutralize B, right? So you all need to understand this, but don't rote learn this. The reason being is because if I switch the case, and this is what most teachers tend to not teach, and because their own conceptual clarity is a little messed up, and students tend to rote learn these things, right? But what if I were to switch the case? Right now I have 25 cm cube of hydrochloric acid of the same concentration in the conical flask. It is absolutely possible that you put the acid in the conical flask, right? So let's suppose I took the acid in the conical flask, and now I've poured alkali A here and alkali B at in the burettes, right? Now, my question to you guys is that for on the left hand side, 30 cm cube, or let's suppose the same, yeah. On the left hand side, 25 cm cube of A was used to completely finish off the acid. But on the right hand side, let's suppose, let's suppose 30 cm cube of B was used to completely finish off the acid. Now, my question to all of you is, in this case, is alkali A more concentrated or is alkali B more concentrated? Think about it, please. Don't rote learn it. If you have got the conceptual understanding here, you could easily devise it here as well. Now, can you zoom out a little bit? Here you go. Okay, so those of you who are saying B is more concentrated are absolutely wrong again, and those who are saying A is more concentrated are right. Now, let me give you the logic behind it. See, on the right hand side, you were looking at it from the perspective of the acid. 20 of the acid was required to completely finish off this, and 30 more of acid was required to completely finish off this. That's why I said B is more concentrated, because for the same amount, a larger volume of acid is required to completely finish off B, right? But on the right hand side, now you want to finish off the acid. Now you want to finish off the acid. Now in on the on when you talk about alkali A, 25 of alkali A was required to finish off this entire acid. But on the right hand side, 30 of B was required to finish off the acid. Now, my question is A more concentrated? I don't want to look at the concentration of hydrochloric acid. Most students get that wrong, because most students think that, we are talking about the concentration of the acid. No, that's already known to us. I want to figure out this concentration. So in one case, in case A, 25 cm cube, or 25 cm cube of the alkali was used to finish off this acid. But in B's case, more alkali was required. More alkali was required to finish off hydrochloric acid, the same amount, which means B lacks power. B does not have enough power to more drops of B are required to finish this off, which means that B is a less concentrated than A, because a larger volume of B is required to finish the same amount of hydrochloric acid compared to this. But if you look at the right hand side, you'll realize that if you look at B on the right hand side, more of acid was required to finish off B, right? So you need to look at them from different perspectives. Yes, we are finding the concentration of alkali, not the acid, please. Yeah. So you need to be very careful. So in this case, A is more concentrated, and in this case, B was more concentrated. And if you still don't get it, I'd recommend watching the YouTube video, once or twice to get your conceptual clarity, or you could even watch Titration. But that's not our main point today. Our main point for it is to just start doing questions. Okay, so after we've understood the thought process, let's look into this. So a student determines the concentration of solution K. So we don't know the concentration of acid, right? Using a method that involves titration. A student measures 20 cm cube of solution K using a pipette, and then the student makes up a solution to 250 cm cube with distilled water. That's called solution N. Remember, solution K is acid. Solution K is acid, right? And solution L is also acid. Now, between K and L, which acid is more diluted? Which acid is more diluted? Between K and L, which acid is more diluted? Obviously, L is more diluted because it has, it's 250 cm cube and that's 20 cm cube. And if you even want to figure out how much more concentrated K is compared to L, you could just take the ratio, 250 divided by 20. What do we get? 250 divided by 20. What do you get? How do we know that K and L are both acid? Because solution K, he said that, involves titration. Oh, solution K is dilute sulfuric acid. He said it at the top. That's why we say read the question carefully. So realize that, K is almost 12.5 times more concentrated than L, because K has a lower denominator, right? Because how do you calculate concentration? N equals CV. And if you want to calculate C, it's N over V. So the lower the volume, the higher the concentration. And you could just take the difference between the ratio between the two volumes to figure out how much more concentrated it's going to be. Now, one thing that you all need to notice here. One thing that you all need to notice here. That thing to notice is that my question to you guys is, let's suppose you take a cup of water and you put, 2 tablespoons of honey into it, right? You put 2 tablespoons of honey into a cup of water which contains 20 cm cube of, let's suppose the water is 20 cm cube or the solution is 20 cm cube, right? And you put 2 tablespoons of honey into it. Now, my question to you is, let's suppose you take the same container right here, the same container, the same 2 tablespoons that you've put in, and you add more water to it. And how much water do I add? I add so much water that I make up a solution of 250 cm cube. My question to you guys is, did you guys change the amount of honey that you put in? Did you guys change the amount of honey that you put in? Yeah, it was 2 tablespoons of honey at the beginning, and even in this 250 cm cube, the tablespoons of honey that you had added initially was 2. Why do I need to tell you guys this? The reason for it is, remember, even if you add more water, even if you dilute it, even if you go from 20 to 250, the tablespoons remain the same, aka the moles remain the same. So the number of moles in 20 cm cube of K, number of moles in 20 cm cube of K are going to be equal to the number of moles in 250 cm cube of K, which is called solution L right now, right? So moles in 20 centimeter cube of K equals the same moles as 250 cm cube of L, right? Okay, makes sense? अच्छा जी, आगे बढ़े. I'm going a little fast because I expect you guys to know a few things, but I still recap things. But if you guys can't keep up with the pace, you guys can always watch it on YouTube later on. You could watch it right now and then slowly and gradually watch it again. Yes, in dilution, the number of moles are always same. They don't change because see, initially you had 2 tablespoons of honey. Think of these tablespoons as moles. So if you added 2 moles initially, even when you added water, the concentration no doubt changed, but the moles remain the same, right? Now, let's talk about this question. Let's start solving this question after I've given you guys the entire idea. Chalo. Name another apparatus that could be used instead of a pipette to accurately measure 20 cm cube of solution K. Obviously, that's a burette. Some of you guys might write, oh my God, sir, why not measuring cylinder, right? Some of the answers that I'm getting is a measuring cylinder. Oh, you dumbo jumbos, a measuring cylinder does not measure up to 1 dp, right? So a measuring cylinder will either give you 20 cm cube, 21 cm cube, 22 cm cube, 23 cm cube, 24, but not 24.0. That's not its least count. It's not that accurate. So the one that can do it accurately is gonna be a burette. Obviously, the disadvantage to that is gonna be that it's gonna be slower. Using a burette is slower. No, 20 is not the same as 20.0 because 20.0 or 24.0 and 24 are not the same thing. No, 24.0 means that you are measuring it till 3 sig fig. Yeah. How is the burette slower? Because using a pipette, you'll be quicker using a pipette compared to, because in the burette, you'll first use a conical a filter funnel, then add it there, and then, then you slowly measure it, and then you open the tap. So it takes a little longer, right? Measuring cylinder is not accurate. I've said it. Yeah. I've said it. अब तो कह दिया ना, दोबारा recording देखो कि why is it not accurate? Because of this 0.0. Yeah. Okay, makes sense. Chalo. Name the container in which solution L is made. Now remember, solution L is 250 cm cube, and the only container that you could use, one of the containers that you could use is basically a volumetric flask, right? You could also call it a graduated flask, not a measuring cylinder. A measuring cylinder is not used to make solutions. The flask that's used to make solution is called what? No, it's not a beaker. A beaker is not used to make solutions. No, 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 no. Nope, 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 nope. It's volumetric flask. Yes, not a conical flask even. Your teachers should have taught you guys this apparatus long ago. You are losing easy marks, some of you. Yes, it's a volumetric flask or a graduated flask. So volumetric flask, it looks something like this, it's like, it has this big base. So, you could mix it and shake it and swirl it. Not a conical flask. It can't hold 250 cm cube. A normal laboratory conical flask doesn't do that. So it's a volumetric flask, or you could even say a standard flask. Erlenmeyer flask is a conical flask. You can't use it. But that's up to you. If you guys just want to write conical flask, that's up to you. But I'm telling you, KR, that's not it. Khair, a pipette is used to transfer 25 cm cube of solution L into a conical flask. Name another piece of apparatus that is used with a pipette. That's called a pipette filler, you know. You could also call it a safety filler or a pipette bulb. You know, you first of all push it inwards, you place it on the pipette to create a vacuum, and then you let it go, and then, you know, the pipette sucks up that liquid. So you could call it a suction bulb, whatever you want to call it, but the better word for it is a pipette filler or a safety filler or whatnot, a filler, blah, 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 blah. Doesn't make a difference. So it's a pipette filler or a pipette bulb or whatnot, pip filler, safety, pipette, whatever. Yeah. The student adds 3 drops of methyl orange to solution L in the conical flask and then place. Okay, now realize, okay, think now. See, you have to read the question very, very carefully. The 25 cm cube of, he basically took solution L, but he pipetted out 25 cm cube of solution L and then he added it to the conical flask. So in the conical flask, always annotate for yourself. In the conical flask, I have 25 cm cube of solution L, which is effectively my acid. Remember, I have 25 cm cube of acid in the conical flask. Now, the student fills the burette with 0.1 mole per dm cube of potassium hydroxide, right? So he's gonna basically perform titration. Why? In order to figure out the volume of neutralization. And once he gets the volume of neutralization or the volume of potassium hydroxide required to completely, you know, devour this, he's going to use the volume and the concentration to find moles. And after he finds moles, he's going to use the equation to find the moles of acid. And he has the moles, he has the volume, he can find the concentration later on. Yeah. Okay, my question to you guys is, now think about it, the logic that I gave you at the start. If let's suppose 25 cm cube was used of potassium hydroxide, and in the other scenario, let's suppose 30 cm cube of potassium hydroxide was used, in which case would the acid be more concentrated? You know, acid's concentration, remember, we already know this, but 25, the acid requires 25 of this, and then let's suppose the acid required 30 of potassium hydroxide. It requires more hydroxide, right? It's potassium hydroxide. So realize that it's going to be more concentrated if it required 30 cm cube relative to 25 cm cube. Yeah. Chalo ji, pad lo. Yeah. So makes sense. That's the logic I gave you at the start. Let's figure it out. The potassium hydroxide is added to the flask until there's no change. Okay, my question to you guys is, when he added methyl orange to the conical flask, always annotate for yourself. Because it's an acid, what's going to be the color of the solution? It's going to be red, because methyl orange gives you a red color in an acid or in acidic solution, and it gives you a yellow color in an alkali. Done? That's concentration. I was just giving you guys examples. What if 25 cm cube of KOH was required, and what if 30 cm cube of KOH was required? We have yet to perform this entire experiment and figure out how much KOH is actually required, right? Khair. Now, the student fills a burette and the KOH is required to is added to the flask until there's a color change, and that color change is going to be from red to yellow. You could write orange, but practically speaking, it's yellow, because we always add the base 1 drop or 2 drop in excess, because we are not, as humans, we aren't that accurate. So it gives me the color of the base, which is yellow. You could write orange if you want, if you're IGCSE students. Yeah, it's up to you, but it should be yellow, you know, practically speaking. Khair. Now he's saying it's added until there is a color change, and that's basically an indication that the endpoint has been reached. What's the endpoint? The endpoint is basically when the indicator changes color. Yeah. And then you have to stop the experiment. And that is when I'll find out how much volume of KOH was actually used, right? State which liquid should be used to wash out the burette before filling the burette with KOH for use of titration. What should be used? A lot of students are saying distilled water, and you guys are wrong. And if you still don't know this, watch the video. Why the acid? The burette has KOH in it. Why would you wash it with the acid? You know, so you wash it with potassium hydroxide. Now, why do you wash it with potassium hydroxide? I swear I've been over this, but you guys don't watch the videos, some of you, you know. So the reason for it is, see, I already know that the concentration of potassium hydroxide is 0.1 mole per dm cube. Listen, without by saying, oh my God, I'm confused, just listen for a moment. Yeah. Yeah. It's easy. Let me just make sure that everybody's listening, tuning in. Okay, listen. I know I took out KOH from the, from the lab, from the cupboard, and it was zero point 0.1 mole per dm cube. Now the problem is that if I wash this burette with water or with distilled water, whichever water, with distilled water, normally we wash it with distilled water, there may be some water droplets left behind, you know and these water droplets, when you add potassium hydroxide to it, they will dilute the concentration of potassium hydroxide. Because of these water droplets, the solution will no longer be zero point 0.1 mole per dm cube or zero point 0.1 mole per liter, because these water droplets would add to the denominator, right? So the concentration would drop. So they basically, dilute the potassium hydroxide. That's why after washing it with distilled water, you have to wash it with potassium hydroxide in order to ensure that the concentration of potassium hydroxide does not get diluted. Yeah, Samir, I've been over this. Okay, when should you only just wash it with water? That's for the conical flask in this case, and you could watch the video. I've been over this. Khair. So that's why we have to watch it. Yeah, some of you guys may say, hey, sir, what if we are very conceptually, we are very conceptually sound and technical? What if we write wash it with distilled water followed by KOH? The examiner will give you mark, don't worry for it. But if you just say wash it with distilled water, that's an inaccuracy, because what will happen is that'll dilute potassium hydroxide for you, and then even the volume of neutralization that you're going to get is going to be greater, is going to be overstated, because you're reducing the power of potassium hydroxide, right? So more of it would be required to neutralize the acid. Khair. So explain why the conical flask is now placed on a white tile. Why is it placed on a white tile? To clearly observe the color change, to clearly observe when the indicator changes color, to clearly and accurately predict the endpoint, whatever. So clearly, to clearly observe the color change of the indicator or whatnot. Of the indicator. Please realize that even if you write to accurately observe the endpoint, to accurately observe this, that, everything is, acceptable. Okay? As long as the spirit of the answer remains the same. Khair, state the color change of methyl orange indicator at the endpoint. So it's basically red to yellow. Yeah, you could even write orange. It's up to you. But practically speaking is normally yellow, because what happens is that you can't, it's very rare to accurately get that orange color. It's always, the potassium hydroxide is always in excess of 1 drop. That's why it turns yellow, because the indicator gives you a yellow color in an alkali. Done? Okay. Now the student does 3 titrations. The diagrams below show parts of the burette with liquid levels both at the beginning and at the end of each titration. So at the beginning, you have 0 0.0, that's the beginning, that's the beginning bit. And that's 24, 24.1, 24.2. So the final one for the first titration is 24.2. It's literally just reading it. And then that's 25, 25.1, 25.2. That's the start. That's the start, and then ending is 46, 46.1, 2, 3, 4, 5. That's 46.5. Yeah. And then in this case, it's 11, 11.1, 11.2. That's right here. 11.2. And in this case, that's 32, 32.1, 2, 3, 4, 5, 6, 7. So 32.7. Yeah. So it's pretty easy. Acha, in O levels, at times this used to be tested before, but now it's no longer tested. It's been quite some time. Sometimes, what can happen is that the reading can look something like this, and sometimes the reading can look something like this. Now, do I think the red reading or the the red reading or the blue reading right here? Do I take the red reading or the blue reading? And in this case, do I take the red reading or the blue reading? So in A case, red or blue, in B case, red or blue. Yeah. Na blue in B red, Na blue in B red, Na blue. Yes, you guys are all right. So remember, just as a rule of thumb, this is called a meniscus forming. You don't need to know why a meniscus forms. It has to do with some things, but it's not a part of our course. But what you need to realize is the way you could predict it is I'll just give you a short tip for it. Wherever the curve lies, wherever you have a minimum point and a maximum point, if you take mathematics, but if you don't take mathematics, just realize where most of the curve lies. So the curve lies right here at the bottom, it's like a buttock at the bottom, and the curve here lies at the top. So I'm going to take this reading, the blue reading for A, and I'm going to take the red reading for B. It has not been tested in quite some time, but hey, it can be. Okay, so you need to also properly read this. It says final initial volume and best titration result. So the final reading is 24.2. Can somebody now help me? The initial is 0.0, and the final in the second experiment is 46.5. Yeah, and the initial is how much? 25.2. Thank you, sir. And then in the third one, it's 11.2, 11.1, 11.2. That's the initial. And what's the final? The final is 32.7, right? Done? Makes sense? Okay. Don't remember meniscus, please, honey. Just remember wherever the curve lies, wherever most of the curve lies, you'll take that. So in A part, the curve lied here at the bottom, and B part, the curve lied here at the top. Yes. Okay. Acha. Now, volume of potassium hydroxide used, you just take the difference. Simple mathematics. Take the difference of the initial volume and the final volume. What do you get? 24.2. And here, 21.3. And here, 21.5, right? Now, which two are the best titration results? Remember, the best titration results are always concordant results. Concordant. What's meant by concordant? Concordant results are the results which are closest to each other. But in chemistry, they are results which are within 0.2 cm cube of each other. You know, But even if you can't find results which are in 0.2 cm cube, in this case, you could see the only difference between the two is 0.2 cm cube, right? So these are concordant results, right? They're accurate because usually what we do is the examiner can ask you, why is this volume largely different from these two? Because the first titration that we perform is called a rough titration. So you could just tell the examiner, the first titration that we performed is a rough titration. Why is it rough? To just speed up things. You just quickly open the tab. You are not that careful in it. You just try to figure out and predict, okay, the volume of neutralization is roughly about 20 to 24 to wait, to save time. Because if you perform the first titration carefully, you're going to slowly open the tab and then just, slowly. So it will take a lot of time. So the first titration, we perform a rough titration. And then the second and third, because now we know where the volume of neutralization is going to lie, then when we reach that point, we then start to, be more and more accurate. That's why this is largely different. Why? Because it's the first titration is usually a rough titration. We're not that careful with it. And you'll perform this in AS level. Yeah. And then these two are concordant results within 0.2 cm cube of each other. But even if they weren't in the exam, even if they weren't in the, even if they weren't within 0.2 cm cube of each other, you had to check out which of the two are closest to each other. So out of these three, which of the two are closest to each other? That's 2 and 3. So I'll tick this and this. And then use the best titration results to calculate the average volume of potassium hydroxide used. So it's 21.3 plus 21.5 divided by 2, you know, the first titration. Okay. What do we get? 21.4 cm cube. Now, see, the most important thing about when you go about these questions is annotations. Keep on reminding us, because the moment the student reaches here, he doesn't even know what's happening, because we've lacked so much. We watch Instagram reels all day long. Our attention span has reduced so much that the moment we figure this out, we're like, oh, what were we trying to do? So annotate it. Oh, that's the volume of potassium hydroxide, That's the volume of potassium hydroxide. And through the information given to me above, I also knew the concentration of potassium hydroxide. And that's what Sir told us. Sir told us that through the entire experiment of titration, you're going to figure out the volume of neutralization, and from the concentration and the volume, you'll figure out the moles of that. And then through the equation, you'll find the moles of the unknown solution. And then once you have the moles of the unknown solution, you'll have the volume of unknown solution. You could figure out the concentration. Yeah. Great. So annotation for myself is going to be here. This was the concentration of potassium hydroxide. This was the volume of neutralization. And see, in the next part, he will ask you to calculate the moles. See, calculate the number of moles in the average volume of zero point 0.1 mole per dm cube of potassium hydroxide used in E. So now you have the volume, you've calculated the average volume, you have the concentration. How do you calculate the moles? N equals CV. And remember, these are the moles of potassium hydroxide. And then in the next part, he'll ask you to calculate the moles of sulfuric acid, right? Okay, so N equals mole concentration is 0.1 and the volume is 21.4. But remember, this is in cm cube and that's in dm cube. So to convert cm cube into dm cube, you have to divide it by 8,000. Easy, easy peasy lemon squeezy. Sir, why is divide? Kill me. It's divided by 1,000 because 1 dm cube, which is 1 liter, equals 8,000 cm cube. So 21.4 is cm cube would be how much? X cross multiplier. X multiplied by 1,000 equals 21.4 multiplied by 1. X equals 1,000 is being multiplied, divided on both sides. So 21.4 divided by 1,000. That's why. Yeah. Hope it made sense. So what do we get? How many moles? 0. Sorry for being sassy. I'm sorry. I'm just messing around. So it's 2.14 into 10 is power minus 3. Okay. It doesn't matter even if you write it in standard form. It doesn't make a difference. 2.14 into 10 is power minus 3. I write it. Yeah. These are the moles. Remember, what did I find? Always write for yourself. I found the moles of KOH. And in the next part, 100% guarantee, God don't help, please help me, but 100% guarantee he's going to ask you to find the moles of sulfuric acid. Let's see, because that is always going to be the idea for titration, which I discussed at the start. See, the equation for the reaction of potassium hydroxide with sulfuric acid is shown. Use the equation to calculate the number of moles of sulfuric acid in 25 cm cube of solution L. So you know the equation. What is it? 2 moles of potassium hydroxide reacted with 1 moles of 1 mole of sulfuric acid. So 2 moles were required for H2SO4, were required for 1 mole of sulfuric acid. Yeah? So my question to you guys is that I figured out the moles of potassium hydroxide, which is 2.14 into 10 is power minus 3. So how many moles would be required? N cross multiply. What do we get, sir? 2.14 into 10 is power minus 3 divided by 2. What do we get, sir? 1.07 into 10 is power minus 3. 1.07 into 10 is the power minus 3. Yeah, you guys are doing the calculations, not me. So if they are wrong, it's on you. Okay. Now, remember, these are the moles of acid in how much volume of acid? These are the moles of acid in 25 cm cube of acid. Remember. So now when he asks you to calculate the moles of acid in 250 cm cube of L, remember, don't confuse this with the first concept. Initially, I told you that if you have 20 cm cube of K, it'll have the same moles as there are in 250 cm cube of distilled water, because the only thing that you did was just add water. So the moles of 20 cm cube of K will exactly be equal to the moles of 250 cm cube of L, right? But remember, when he pipetted out 25 cm cube out of this L, now these two moles would be different. Yeah, it'll be 10 times different. Let's see, So remember, these two would be different, but these two would be the same. Yeah. Okay. Now, if I want to figure out the moles in 250, so in 25 cm cube, I had how many moles? I had 1.07 into 10 is power minus 3. So in 250, I just multiplied by 10. But in 250, I'd have n. Those of you who don't know. So n equals, what do we get? 0.0107. So it's going to be roughly 1.07 into 10 is power minus 2. These are the moles in 250 cm cube. Now tell me something, peeps. Tell me something. The moles that you figured out, would they be, how many moles of sulfuric acid would be there in 20 centimeter cube of K? Remember, 20 cm cube of K and 250 cm cube of L would be the same. You know, back in our day, let me tell you something. Back in our day, our friends used to rote learn this. So what they used to do is they used to be like, hey, the examiner used to do this. The moles that would be here would be half of this, and then this and this, you'd just add, you'd just make -3 to go from -3 to -2, and then you'd just make these two equal. That's how my friends memorized it, because the Cambridge pattern became so predictable. Fair. Let's do this. So moles of 20 cm cube of K equals, and now we also know the logic behind it. So it's not just rote learning, we know the logic. So the moles would be the same. That's 1.07 into 10 is power -2. Now calculate the concentration of solution K. For K, remember, for K, these are the moles for K. And what's the volume for K? Take the correct appropriate volume. That's the volume for K. So you have the moles of K and the volume of K. So it's what? N equals CV. You have the moles, which is 1.07 into 10 is power -2. You need to find C. What is V? 20 over 1,000. Why? Because I need to convert cm cube into dm cube. Remember, this has never been tested before, but if the units are same, if that's cm cube and that's also cm cube, you won't divide it by 1,000, because cm cube and cm cube would cancel out. If this was dm cube and that's what dm cube, the dm cube and dm cube would cancel out. The only reason why we divide it by 1,000 is to convert it into dm cube. Yeah, so that the units cancel out. So what's C? 0.535, yeah? 0.535. Acha. A lot of students ask me this, what is the correct number of significant figure? What is the correct number? Sir, what if he said deduce the number of moles in 20 cm cube of L? Well, he wouldn't have said that, but if in 25 cm cube of L there were where is it? In 25 cm cube, if there were these many moles, in 20 there would be N. Yeah, you wouldn't know. And then you would figure out in 20 of L, not of K. K and 250 of L. That's it. A lot of students ask me about significant figures. There's a very beautiful rule. There's a very beautiful rule for it. If you've joined late, watch the initial part of this lecture. It contains all the understanding. Now, my question to you guys is, no, sorry, some students ask me, sir, what are the correct significant figures? Remember, if there is an apparatus that gives you values correct to 4 significant figures, and then you have an apparatus that gives you value correct to 2 significant figures, what should your answer be in? Your answer should be in the value of the one that gives you lower significant figures. So your answer should be in terms of 2 significant figures. And the reason for that is, you don't need to know the reason, you will learn it in AS Physics, the first chapter of AS Physics. But the reason for that is that if you have 4 sig fig at one point and you have 2 sig fig, which means this is less accurate. If you're using something which is less accurate, how can you get the answer which is more accurate? More accurate and less accurate, you cannot go, you cannot improve the accuracy here. So the apparatus that is the least accurate, your answer should contain those significant figures. Remember, the apparatus which is the least accurate, your answer should contain that many significant figures, right? Now, one more question to you all is that if I look at my my question here, the concentration of potassium hydroxide that was given to me was in how many significant figures? One. The preceding zeros are not significant figures. The zeros after the digit are significant figures. So that's 1, 2, 3. These are 3 significant figures. So the concentration that I'll give would also be in 3 significant figures. Yeah? Done? I shall watch the recording again. If you don't understand how 20 cm cube and 250 cm cube are the same, please watch the recording again. And it's even uploaded by the name Titration, one of the recording. Yeah. Those who have joined late, please either wait for the titration bit to be over or just watch the recording later on. But if you are here, you could just wait for this this experiment to be over, because we'll move on to the next questions. Okay. It'll be uploaded onto YouTube at Carboxyl. Yeah. Okay. A different student does the same experiment using 30 drops of methyl orange instead of 3 drops of methyl orange. Remember, you need to always figure out what's in the burette and what is in the conical flask to answer any question related to titration. Never forget this too, right? So in the conical flask, what did we have in the conical flask? We had the acid, and in the burette, we had potassium hydroxide. Don't rote learn it. Please don't rote learn it. Thank you. So now see, the examiner told you that methyl orange is acidic. How is it acidic? Why is it acidic? I don't give a, I don't care. I don't care. The examiner told me it's acidic. I will say, okay, thank you, examiner. You told me it's acidic. I'll believe you. It's acidic. Okay, great. So you already had the acid in the conical flask, and he's saying methyl orange is acidic, and instead of using 3 drops, now you're using 30 drops. 30 drops means that if you had 25 cm cube of acid here, it's no longer 25. You've added more acidic drops. You've added more acidic drops. So what should happen to the volume of potassium hydroxide that would be used up? What should happen? Should more potassium hydroxide be used or should less potassium? See, that's why I'm saying don't rote learn it. Use your common sense. You've increased acidic things here. So potassium hydroxide neutralizes acids. So if you've added more drops, then more of potassium hydroxide would be used. That's so logical. So a larger volume of potassium hydroxide would be used. And that's it. So a larger volume would be used. And he's saying explain it. So write your conceptual understanding. A larger volume of potassium hydroxide is used. Why? Because now we've understood the concept. So ATP has the answers in the question. You just need to decipher them, right? So a larger volume of KOH is used. He's saying, no, don't just state it, explain it. Why? Because the methyl orange adds more acid to the conical flask. So more potassium hydroxide is used, needed to neutralize it. So I could say, hey, the methyl orange adds more acid to the flask. Or you could even say adds more H plus ions to the flask. Because anything that's acidic is basically talking about H plus ions, right? So it adds more acid to the flask. Therefore, more KOH or a larger volume of KOH is required to neutralize it. Khadija, you'll have to look at the circumstances. So I don't remember it. You could send me the picture later on. Okay, this was the question. Sir, how are you a chartered accountant if you took science subjects and everything? Yeah. When life gives you lemons, you make some lemonade. This is my hobby. I do this as a hobby. I do this to get my mind off of finance things. Sir, I've DM'd you, but you haven't checked. It's been 3 days. Oh, I'll check it, inshallah. I'll check it, Hania. Don't worry about it. I'll check. I've just been too caught up with a lot of clients and, it's just major things. Okay. Now we're done with the first question. We're going to go over question number 2, which is again titration. And then question number 3 talks about, because these are two different things. Question number 3 talks about the investigation of precipitation reaction. This was very unique. And this came in 2024, October, November 6/1. So that was very unique. You guys can read this question and remember, read the question carefully. And I'm just gonna drink water. Yeah, you guys can read the question for a moment. I'll give you 2-3 minutes to read it. But when you're reading the question, annotate it for yourself. So you're such a nerd. No, I'm not. Please show question 1 end part. Don't just copy it. Don't just copy it. Try to understand it. This is. Sir, I'm gonna subscribe to your YouTube channel. You're so underrated. I love you. I swear to God, you explain things so easily. I love you so much. I'm gonna drop so many comments and will make sure that you are famous. This is my job. I've also told Zynamatics about. Oh, thank you, yaar. Bas. I'm highly obliged, yaar. Thank you. Yeah. How many yearlies are enough? Chill. करते जाएं. When's A level starting? Hopefully from the mid of July or the 1st of July, because Sir Abbas is pressurizing me to start it from the 1st. But I want to delay it so that you guys get an idea of how teachers are teaching. Yeah, I want to start it in August or September, but because I want to I want to make sure that you guys get an idea of the teachers in the market as well, and then you could have enough comparisons. Hi, khair. Read the question, guys. I'll drink water. YouTube channel name is Carboxyl. Carboxyl. I've written it. Do you teach A levels? A levels? अब तो A levels आपसे ही करना है. Perspective changed. Oh, Abu Bakr, thanks, man. The word A levels is too depressing to my ears. Ah, it's nothing. It's the easiest. A levels is just 3 subjects. O levels was more difficult than A levels, to be honest. What finance guy song? I've not heard it. Yeah. Will you explain delivery of gases? I'm explaining the major chunks. Hey guys, you have a paper 2 days, in 2 days, or even one day, because yeah, the next day you have paper in 2 days. So stop thinking about A levels for now, and even stop thinking about which subjects to take. पहले तो कर लेना. पहले let's first do O levels and IGCSE, and then we'll do A levels as well. I swear I'll take a session with you all after you guys are done with your O levels. I'll take a session with all of you to guide you which subjects to take and how to take it and whatnot. It's gonna be free, Zoya. The A levels isn't gonna be free. The sessions are gonna be free. Don't worry. You guys have a paper tomorrow? What? I thought it was day after tomorrow. Isn't it on the 15th? That's why so many students are joining in. Yeah. 160. Oh, English is tomorrow. Chill, guys. You guys gave me a heart attack. It's day after tomorrow. Chemistry is tomorrow. Okay, for some students maybe who are abroad. Maybe for students who are abroad. Yeah. Ore sajana. Okay. Now, let's talk about question number 2. A student investigates the reaction between, oh, sorry, this wasn't, oh, yeah, that's question 2, sorry. A student investigates the reaction between hydrochloric acid and aqueous. Now I'm going to go a little quick on this on this question. The student does 2 experiments. Experiment 1, fill the burette with aqueous sodium hydroxide and run some of the aqueous sodium hydroxide out of the burette so that the level is on the burette scale, right? So he added sodium hydroxide right here in your burette. Remember this, always annotate, always annotate. So sodium hydroxide is in the burette, and read it a little quicker. Sodium hydroxide is in the burette, and this is actually a precaution as well. He can test it he can test it in the upcoming exam, and he can say, why did you let some of the sodium hydroxide out of the burette? So what he does is, once he fills it up, he removes some of it, because realize that the burette may be filled till here and the zero mark may be a little below it. So he wants, what he wants to do is that he wants the level to be on the burette scale, except rather than being above zero, he wants it exactly at zero. That's why he wants to run some of the sodium hydroxide out of the burette. And the second reason why he's doing it is to fill the burette jet with sodium hydroxide as well. So to fill the jet with NaOH. Now, why does he do that? To have more accuracy, right? So to fill the jet with NaOH. So these 2 reasons can be asked. Why do you let some of the sodium hydroxide out? Yeah. Now, record the initial reading on the burette scale. I'll do that. Absolutely. Okie dokie. Use a measuring cylinder to for. Oh my God. Whenever he writes something like this, because I've been reading these questions on and on and on and on, now I've recognized a pattern. Because if he's using a measuring cylinder to pour 25 cm cube of dilute hydrochloric acid, that's an inaccuracy. What should he do? He should use a pipette. And you didn't find it today. I'm watching you live. Thanks, Mohammed. It's a pleasure. So you should use a pipette. And remember, he's gonna literally ask me this question in the future. He's gonna ask me this question. Abhi aage jaake, let's see. He must have asked me this question. So a pipette is more accurate than the measuring cylinder. But why would think about this? First of all, students are usually dumbo jumbos. That's why he may not be aware of accuracy. But why would he be using a measuring cylinder rather than a pipette? Even though, let's suppose, even though a student knew that a pipette was more accurate than a measuring cylinder, why would he use? My grade was A stars, Shayan. Don't worry about it. I was also in the Pakistan national chemistry team. I've also written research papers. You are in good hands. So in my day, I did a lot of things in chemistry. Chill. Yeah. Yeah. Just because I'm a finance guy doesn't mean I'm not good at sciences. Okay, yes, you are right. Who said this? Hasib said. So Hasib said even though he may knew that the pipette is more accurate, the disadvantage of using a pipette is that a pipette takes longer. You know, you have first of all you have to squeeze the pipette filler, then plug it on, and then whatnot. You know, so it's gonna take some time. So what he wants to do is he's using the measuring cylinder because you could say that the disadvantage of a pipette is that it takes longer. But it's a dumb student, you know, in this case, the student is a dumbo jumbo because he doesn't know that accuracy is more important, you know. There's no fire, you know, somewhere. So you just don't have to be lazy. Use the pipette, but it takes longer. That's why probably he may have used the measuring. So remember, the things that I'm telling you, they're all precautions and they all can be asked. Rafi, I don't know what to do for English. I'm a chemistry teacher, dude. Chill. Okay. So stand the conical flask on a white tile. Again, so what he did was he poured 25 cm cube of hydrochloric acid in the conical flask. Remember, see how I'm annotating it for myself, 25 cm cube. Great. And he's saying that he makes the conical flask stand on a white tile. Why on a white tile? To observe the color change clearly, you know, the color change, or to accurately, you know, to accurately observe the end point, you know. All are right as long as the spirit of the answer is correct. So observe the color change more clearly, to observe the end point clearly, you know, to observe the end point more accurately and whatnot. Khair. Adds 5 drops of methyl orange to the conical. Those students who don't read this, they mess up the ATP because the question requires more reading. Khair. Uh, Cheyenne, why do we use black tile? I've solved that question because you're not using logic. It's not necessary. Maybe the precipitate that's being made is white. So for that, he's using a contrasting color, which is black, to observe it. But in these cases, you know, to make the, yeah, that's why. Yeah. But you need to read the question. Don't just bluntly ask question. Okay, in that case, it was totally opposite to it. That's why I first of all explained the entire logic behind titration. Okay, it can be like this, it can be like this. Just you need to be more logical. Yeah. Khair, let's come back to the question. So, when he added methyl orange indicator to the conical flask, what do you know? What do you know? Because it's an acid, methyl orange is going to give you the color of the solution is going to go red, right? And then at the end of the titration, it's going to obviously be yellow because a drop of sodium hydroxide may be in excess, will be in excess effectively. Khair. Slowly add aqueous sodium hydroxide from the burette to conical flask. Why is he adding it slowly? All of these things you need to know. Why is he adding it slowly? Why? To obviously, it's logical. Why would you add it slowly? Why not very quickly? Because you may overstate the volume of neutralization. You may add more sodium hydroxide than required, right? So you may add more NaOH. You may add, if it's not slow, if it's not slow, if it's not slow, you may add, you know, more NaOH than required. You know? So a lot of things you could write. Okay. Then you know, he's also swirling it. Why is he swirling the flask? To mix the reactants, obviously, to make sure that sodium hydroxide reacts completely with hydrochloric acid. So to thoroughly mix the reactants. And remember, if it was a question for temperature change, if it also required temperature change, then you would have also said to evenly spread the temperature because you want to measure the temperature with the thermometer, right? So if it was a temperature question, you would also say to mix the reactants and to evenly spread the heat. But since we don't care about temperature, I'm just going to say, hey, he's doing it to mix the reactants. Done. And I think until the solution changes color. Well, when the solution changes color, we know that's the end point, and we're going to stop our titration, sir. And then, you know, once we stop our titration, uh, we're going to record the volume of neutralization, and that's going to be it. So record the final reading of burette. So here you recorded the initial and then the final one. And then in experiment 2, empty the conical flask, rinse it with distilled water. So he rinsed the conical flask with distilled water, done. Refill the burette with sodium hydroxide. And why did he rinse it with distilled water? To probably remove, you know, the methyl orange or the impurities or the contaminants from experiment 1, right? Now, you guys might wonder, sir, do we need to also wash the conical flask with hydrochloric acid to remove the contaminants from experiment 1, right? Contaminants from experiment 1. Right? Now, or to clean it, you would also say to clean it and whatnot. Now, also, why did you not wash it with hydrochloric acid? That's my question to you guys. Why did you not wash it with hydrochloric acid? Why? Why didn't you wash it with hydrochloric acid? Like once you wash the conical flask with distilled water, why don't you wash it with hydrochloric acid as well? Because water may remain. Remember, even though the water droplets may remain here, the moles of hydrochloric acid would not change. The hydrochloric acid particles are going to be the ones which would react with sodium hydroxide. Listen to it again. Sodium hydroxide is going to react with not the water particles, but with hydrochloric acid particles. So remember, even if you have water droplets here, it does not make a difference. But remember, if I have water droplets here, that would dilute the concentration of NaOH. In this case, NaOH is just being used to figure out how, in this case, the HCl is just being used to figure out how much NaOH is gonna be required to neutralize it, right? And the NaOH particles are just gonna react with the HCl particles, not the water particles. So even if you have water particles here, it does not make a difference. Khair. Refill the burette with aqueous sodium hydroxide, record the initial reading, okay, and then he's going to perform. Now, use the measuring cylinder, again, inaccuracy, it's better to use a pipette because it's more accurate, of diluted into a conical flask, add 0.50 grams of calcium carbonate powder to the conical. That's why I chose this question, because it's one of the difficult questions, yeah. Till 11 p.m. I'll go till 11 p.m. inshallah, yeah. Okay, so he added 0.5 grams of calcium carbonate powder to the conical flask and swirled the flask. See, now there's a difference. In experiment 1 and experiment 2, what's the difference? In experiment 2, this Dumbo Gumbo Mumbo student, what he did was, he did everything the same. You had NaOH here, you had HCl here. See, you even need to know your reactions. And he added calcium carbonate. What a dumb man. Or maybe not dumb. Maybe he just wants to test you. Because if you add calcium carbonate to hydrochloric acid, what's going to happen? No, Isa, water is not gonna take part, because realize that NaOH is an alkali. Alkalis react with acids, not with water particles. So even if water particles are present here, it's gonna react only with HCl. So the volume of neutralization that you're gonna get is gonna be accurate. But remember, if you don't wash the burette with NaOH after washing it with distilled water, there may be some water droplets left, which would dilute its power, which would dilute the concentration of NaOH. In this case, we don't care about HCl's concentration here. Why? Because HCl volume is gonna be the volume of HCl that you have is 25 cm cube, and only 25 cm cube would react with NaOH. We calculate the concentration of HCl not by looking at the flask, but by calculating the moles, which we find out from here, and then using the equation to find the moles of HCl, and then you use N equals CV. So this doesn't change, yeah? Okay, my question to you guys is, this is a beautiful question. It's one of the difficult questions that was tested, Here, this was one of the difficult. Now, think about it. You have acid here and you have a weak base. Boom! Your acid-base theory should click here. Your acid-base theory should click here. Yeah, what should be the acid-base theory? Taha, listen to this again if you don't get it. Listen to it again, or go on to YouTube. I've uploaded titration video there. Watch that. Khair. What should happen? Your acid-base, come on. That's a beautiful question. I did say it. Okay, so the calcium carbonate is going to react with hydrochloric acid. Calcium carbonate powder, and especially when you added it in a powdered form, because in powdered form the surface area is going to be high, the frequency of collisions are going to be high, and the rate of reaction is going to be high. It's going to be very quick. So HCl is going to react with calcium carbonate. It's going to form calcium chloride plus H2O plus carbon dioxide. It's a metal carbonate. The hydrogen in the acid and the O in the weak base is going to give you H2O. The carbon and the oxygens are going to give you carbon dioxide, and the calcium and the Cl are going to give you CaCl2. Why is it CaCl2? Because calcium has a charge of 2 plus Cl is 1 minus, cross multiply, or you could say for one calcium ion you need 2 chloride ions. Done? Bakar chhod do. Forget about distilled, mistilled. Why? When do you wash it with this? You could watch that later on YouTube. Yeah. For now, just focus here. It'll be uploaded on YouTube. Don't worry. Rafi, I'm not an English teacher. Please stop asking what should you do for English tips. Okay, great. Now think about this. Logically, ab sochiye. Because see, your teachers, they don't do these experiments with you. They don't make you, normally they don't, ignite that thought process, that critical thinking. But if it were me or any students who saw this experiment coming, he'd realize that this calcium carbonate, what would it do to the acid? What would it do to the acid? it would actually decrease the amount of acid that you have, right? So NaOH, would more NaOH be required or would less NaOH be required? That's my thought process going behind this. Yes, Zoya, why more? If some of the HCl reacts here, a little is going to be left. So less NaOH would be required, Sir, you used your ATP tips in bio paper 4. Glad I watched your video. That's awesome. Yeah. So realize this thing. Okay. He stand the conical flask on a white tile. We know the reasons for that. Da 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 da. Slowly add sodium hydroxide. You are swirling the flask. Blah blah blah. And that's what happens. So experiment 1. That's the initial. That's the final reading. Let's look into it. So it's 0, 0 0.1, 2, 3, 4, 5, 6, 0 0.6 right here, if I'm not wrong. And that's 19, 19.1, 19.2. So that's like 19.2. So the initial reading, in fact, for experiment 2, see that's experiment 2. The initial reading is what? 1.5, 1.6, 1.7, 1.8. Yeah. And the final reading is 7.5. The larger graduation is 0.5, 7.5, 7.6, 7.7, 7.8, 7.9, and that's basically 8. So that's 8.0. So can you guys tell me the initial and the final reading? Can you guys tell me the initial and the final reading? Yeah. 0.6 initially and 19.2 final. So 19.2 and 0.6. And in experiment 2, it's 1.8 initial and 8.0. Yeah. Rate of reaction, we're going to do it. Don't worry. Nabil, chill. Let's do it in a while. After this question, it's rate of reaction. So, yes, Kafi is right. Kafia is saying, sir, if calcium carbonate was in excess, all of it would neutralize the acid, then no change would be seen. Yes, you're right. The indicator would just go yellow after the first drop of NaOH. The indicator would just go yellow after the first drop of NaOH, right? So you're right. You're right. Absolutely. But we don't know if it's in excess, right? We don't know. Because why would he use it in excess? Then there's no point in doing this entire experiment. He's just going to make the entire acid get used up, right? Khair. So the volume of neutralization in experiment 1 and 2, what do you get? Minus, subtract. It's 18.6 here and 8.0 minus 1.8. It's 6.2. See, that's what I told you. Your brain should click here. More NaOH was required here and less NaOH, less volume of neutralization is required here. What's the reasoning for it? The reasoning for it is pretty simple. The calcium carbonate actually used up the acid. So less acid was left for it to be neutralized by sodium hydroxide. So a smaller volume of sodium hydroxide was needed. मजा आ रहा है मजा आ रहा है sir. I love it. I am understanding things. See, that's why use logic, use common sense. State the color change observed in the conical flask at the end points in both experiment. In both experiment, what is it gonna be? In both experiment, you started off with red and you went to yellow. You could also write orange, but better is yellow. That's I'm speaking from professional judgment. Yeah. What if you write 8 instead of 8.0? You're gonna get a mark deducted because you have to write it till 1 dp for the burette. You should be knowing this at this point, so you're gonna get a mark deducted. And for a measuring cylinder, if it's 20 cm cube and you write 20.0 cm cube, you're gonna get a mark deducted because burette a measuring cylinder would give you this, not this, whole numbers. Always keep in mind whole numbers without a thing. Yeah. Yellow or orange, is up to you. Doesn't make a difference. Forget about the marking scheme. Yeah, marking schemes can change from time to time. Always have. Shamin, I went over it even now. Somebody said sometimes the black tile is used. They can't. The black tile was used in a paper because the precipitate that was forming, the substance that was forming was white. So, you used a black tile to clearly observe the color. You used a contrasting color. So remember, keep things simple and read the question carefully. That's what's going to give you the marks. If you don't read the question carefully, you're going to always be confused. In one case, I remember that. In one case, I remember that. You're just going to get confused. So the examiner will always mix things up just to see your conceptual clarity and how clearly you keep yourself cool, calm, and collected. Here, when 0.5 grams of calcium carbonate is added to conical flask in experiment 2, a gas is produced. Suggest the identity of the gas. We already went over it. The gas is carbon dioxide gas, CO2, or you could even write carbon dioxide. State why there is no need to rinse the burette. In experiment 2, the conical flask is rinsed with water, but the burette is not rinsed with water. See, I told you. Why would he rinse the burette with water? Is he stupid? Because if he rinses it with water, there may be some water droplets left behind in the burette, which would dilute the concentration of sodium hydroxide, right? So to ensure the same concentration of sodium hydroxide. Or you could also say, okay, hey, in experiment 1, NaOH was used, and in experiment 2, NaOH is also used. So to ensure that the since the solution is not changing, it's NaOH before and it's NaOH right now, it doesn't matter. So you don't wash it with water. Burette is not rinsed with water. Why? Why is there no need to rinse the burette with water? Because the solution is the same. That's why you don't wash it with distilled water. Because the same NaOH before with the same concentration. With the same concentration. With the same conc. It was NaOH before and NaOH after, right? If this was NaOH in one conical flask, if you used in one type burette, you used NaOH, and in the other, you used potassium hydroxide, then you would have washed it with distilled water. But remember, what would you do then? Even if you had washed it, then it would have been a must to wash it with distilled water because you're now pouring KOH into it. But after washing it with distilled water, what would you have done? After washing it with distilled water, you would wash it again with KOH. KOH. Yeah, you would wash it again with KOH. But in this case, it's just NaOH, NaOH. It's the same. Great. I hope this conceptual clarity is getting to you. Why don't they dry it? Why? Because the opening of the burette is pretty small, right? Firstly, the opening of the burette is pretty small, so you can't insert, a cloth into it. And even if you do, the cloth may be contaminated. So that's why. Yeah. Explain why the conical flask is rinsed with water. Obviously, to remove impurities from experiment 1. To remove, and you don't need to wash it with, HCl. To remove impurities from experiment 1. The conical flask is not dried after being rinsed with. See, all the questions are being answered. The conical flask is not dried. Why is it not dried? Because realize that the base at the top, the NaOH, would react with the particles of HCl, the 25 cm cube of HCl, not with the water particles, So the volume of neutralization for NaOH would be the same. And then from the volume and the concentration, you find the moles, and from the moles of HCl, you then find the mole, you have the moles, you have the volume, and you find the concentration. So what am I going to say? I'll say the moles of acid do not change. The moles of acid do not change. NaOH would react with the same amount of moles. The moles of acid do not change, which means, what does this mean? What does this statement means? It literally means that NaOH reacts with the acid particles, not with the water particles. Not the water particles. So it doesn't make a difference. Conceptually, try to understand things conceptually. Yeah? Is February, March 2025 paper zaruri? No, not really. Not really. Because I went over the trends. Before you. I did my trends thingy. So I went over all the trends. It's not necessary that it's exactly the same as 2025. Yeah? इसमें तो ड्राइंग की बात कर रहे हैं. Where is it drying? State how drying of the how drying of the conical flask affects the volume of hydrogen. Yeah, that's what it is. That's what you do. If you dry it, the acha ha ha ha. Okay, I get it. Okay, chill. I was giving you guys the logic behind the question. I didn't read the question carefully. I was just giving you guys the logic as to why. Let's just as to why you don't need to as to why you don't need to wash it with hydrochloric acid. But he's saying, why is it not dried after being rinsed? Sorry, I didn't read the question. He's saying, why is it not dried? He's not saying why is he not washing it with hydrochloric acid. He's just saying, why is it not being dried? Because it doesn't matter. the water amount does not change the moles of the acid. It's the same explanation to it. You don't wash it with hydrochloric acid, or you don't even need to dry it, because the moles of the acid that will react with sodium hydroxide would be the same. So the answer to that is the same, actually, in fact. So the moles of the acid would that would react with NaOH, or the particles of acid that reacts with NaOH, remains the same. Shamin, we've been over this, that the moles don't change. Even if you dilute something, the moles remain the same. We literally did this. Moles aren't in O levels in ATP. Oh, no, 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 Zoya. No, this entire thing is moles. Titration is what? It's all revolving around mole calculations. We've been doing this. No, it's highly expected to come. Here, you know. Okay, wait a minute. Some of the students still may have a confusion. Okay, let me clear this. I don't want to speak on this again and again, but let me clear this once and for all. Some students are saying, sir, but the concentration of HCl would get diluted here. The concentration of na. Yeah. And this is the question that should come in my mind as well. But I'm ignoring it because I'm trying to, just work my way into just giving you guys the idea that the particles of HCl would react with NaOH. But if you want me to, go in depth into it, realize that you don't calculate the concentration of HCl from this conical flask, do you? The students who are saying this would get diluted, you don't calculate the concentration of HCl like this. That's why I gave you the initial understanding of titration. What do you need from this entire experiment? You need this volume. And the volume is going to remain the same because NaOH would only react with HCl particles. So if the volume is the same, you use this volume and the concentration of NaOH and the volume to figure out the moles of NaOH, and then you use the equation to find the moles of HCl. And then you calculate the concentration of HCl not through this conical flask, but through the equation, which is N equals CV. Yeah. So you got the moles through the equation and you have the volume, which is fixed. That's 25 cm cube. Yeah. You're not, even if the water droplets are here, you're not adding it to this volume. Now you all got it. I did not want to speak on this, but if everybody's saying, oh, makes sense, oh, makes sense, oh, makes sense, you should have connected the dots on your own. That's awesome. I love it. I love it. Sir, I am recommending you to all my juniors. I've never seen such an awesome explanation. And oh, thank you. You'll find it on YouTube at Carboxyl. Carboxyl. You'll find all the new videos there. Sir, बेइज्जती तो ना करें. Okay. Compare the volumes of aqueous sodium hydroxide needed to reach the endpoint in experiment 1 and 2. You have to compare them. It's more in experiment 1, right? Why is it more? See, in experiment 1, it's 18.6, and experiment 2, it's 6.2, right? Because you realize that you used calcium carbonate, which whatever. So 18.6 minus 6.2. What do you get? 18.6 minus 6. Yay, guys, listen to me. If when I start teaching A levels, it'll be announced everywhere on YouTube, or you just make sure to stay updated. Please don't worry about YouTube now. Just worry about your O level paper. So he's just saying compare it. Don't tell me the why, just compare it. So experiment 1, volume is greater or larger by how much? 18.6 minus 6.2. By how much? By 12.4 cm cube. And literally that's what's giving you marks. One for 12.4 and one for stating that it's larger. Explain why different volumes of aqueous sodium hydroxide are needed in experiment 1 and in experiment 2. Oh, now we know. Now you are asking me explain why. It wasn't you dumb person who added calcium carbonate in experiment 2, you dumbo jumbo. So it's different because in experiment 2, you added calcium carbonate, in experiment 2, you dumbo mumbo. And what happened because of that? That used up HCl. That used up some of the HCl. Let's write some of, not all, used up some of the HCl. So let's always be conceptually clear about things. So less NaOH, less volume or lower volume of NaOH was required. Boom. That's it. Okay. Calculate the volume of aqueous sodium hydroxide needed to reach an endpoint if experiment 2 is repeated using 0.25 grams instead of 0.50 grams. It's so easy, it's simple mathematics. If in 0.50 for 0.50 gram, the volume of neutralization was how much? The volume of neutralization was 6.2 cm cube. So for 0.25, how much should it be? See, if you've halved the volume of, that's where you guys get confused, because what you guys tend to do is cross multiplying, right? But realize, if you have, this is where the logic comes into play. If you halved calcium carbonate, more of the acid is going to be left behind. Isn't that true? More of the acid is going to be left behind. So more acid would be needed. So it's not going to be half the sodium hydroxide. It's going to be double the sodium hydroxide. So don't just do cross multiplication everywhere. It's going to be what? See, the reason why I wrote it like this, because I wanted to show you, if this is half, double of the acid would remain. So double the amount of NaOH would be required. So instead of 6.2 multiplied by 2, you would get 12.4 cm cube. So don't plug in cross multiplication everywhere. Why is it 12.2? See, why is it 2 marks? Because one for 12.4, sorry, and one for CMQ. In titration video, you saved my life. I can do easily the questions, please. That's awesome. Thank you, Nabil. Thank you, man. Explain again. See, Zoya, listen. When you added 0.50 grams right here of calcium carbonate, it used up some of the acid, right? But now, instead of adding 0.5 is ADA, right? Instead of adding 0.5 grams of calcium, see, instead of doing stupid mathematics, just think about it logically. Instead of adding 0.5 grams, what is calcium carbonate doing? It's using up HCl, and that's why, less NaOH is required. But if you, instead of using 0.5 grams, now I've, half the amount, 0.25 grams. So now if I use half of calcium carbonate, he's going to take up what, let's suppose initially he took up 10 cm cube, So now he's going to take up half of, and in the conical flask, let's suppose there was 25 cm cube of acid. So with 0.5 grams, he took up 10 cm cube. But with 0.25 grams, how much HCl is he going to take up? He's going to take up 5 cm cube. So how much more acid is going to be left? Acid is going to increase in amount. More acid is going to be left in the conical flask. That's why more NaOH is going to be left. More NaOH is going to be required. Make sense? Till 11 p.m. This class goes till 11 p.m. Zoya, makes sense? Because yes, you are absolutely right that 0.5 grams will react with more hydrochloric acid and 0.25 would react with half of the amount. And that's what we're all saying. 0.25 would react with half of the hydrochloric acid, but that would mean that there'll be more HCl in the conical flask. And if there's more HCl in the conical flask, more NaOH would be required. Oh my God, that was kind of mind-blowing. What's mind-blowing about that, Umar? It's just common sense. But yeah, common sense is not very common in common people. Forget about the paper code. I've shared this. It'll also be present in the YouTube description. So you could go on to the latest video and there's going to be in the description. Describe how the reliability of these results can be confirmed. How do you go for reliability? You could just repeat the experiment and take the average, yes, and compare the results, Repeat the experiment, not take the average, sorry. No, hold up. Sir, Zymatics के साथ start chemistry session. Oh नहीं, Zymatics is the big man. खैर, repeat the, चलो देख लेते हैं somewhere in the future. Repeat the experiment and compare the results. Why not take the average? Compare the results. We just compare the results with each other. Are they correct or not? Why not take the average? That's a good question. Why not take the average? You don't take the average because you're not performing, you are performing titration, but the end goal is not to see is not to take the average of volume neutralization and find out the concentration. It's just to see the effect. What average are you going to take between the two? Are you going to take 18.6 plus 6.2 divided by 2? It doesn't make sense. So it's just to figure out, if you added calcium carbonate to it, what was the volume of it? You can't take, there's no common sense taking these two average. Why? Would the average of these two be the volume of neutralization? No, they're completely different. In one, he's adding calcium carbonate, and in the other, he's not adding calcium carbonate. Will there be a class tomorrow? I hope so. I'll try my best because I have to, I have a client to cater to. Yeah. Okay, khair. These were one of the two most difficult. I've done 2 titration questions which are uploaded onto YouTube. They were 2 of the most difficult titration questions, and even these 2 were two of the most difficult titration questions. So officially, if titration were to come, you guys should ace it. Just remember to watch to read the question carefully and watch the previous recording as well. Now we're gonna move on to uh, rate of reaction questions type of thing. This was a unique question. I don't think it's a rate of reaction time, but I think it was a little unique. Yeah. Hmm. This was a unique question that came in 6-1. Remember, it's O levels as well as IGCC, but the idea behind taking the class today is to Zoya, please watch the recording later on. The idea behind taking the class today is to make you confident um, into reading the question instead of just haphazardly skimming over it and da 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 da. You should just take a deep breath, read it carefully, but don't take too much time because your practice should be up to the mark. You can't just waste your entire time on it, but read it carefully and quickly annotate it. Okay, I've done this, I've done that, da, 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 right? So now this was a unique question. No matter what question is tested in question number 2, no matter whichever question is tested, is going to be a graphical question, either titration or a graphical question. But whatever is tested, remember to read it. See, this was a new question which was tested. It wasn't tested in any of your variants. It was tested in 6-1. So you guys can read it and understand what's happening. Remember, you need to know your solubility rules and you need to know how to prepare different salts. I'll teach that at the end of the class. I'll drink some water and eat some chips, and you guys can read this. Thanks, Rania. Thanks, kiddo. Sir, I am telling everybody about you. Loudspeaker, I swear to God, all my juniors will study from you. I found you so late, but I will make sure that all the others benefit. Why are you so underrated, sir? This is not fair. Hey, chill. I'm fine. Thanks. Thanks for the wholesome message again. Thanks for making chem interesting. Welcome, Wally. Use pipette instead of what? Oh, yeah, you could have said that, but it's reliability of results. It's not the accuracy of results, kiddo. So if it was the accuracy of result, you could have said, hey, use a pipette instead of a measuring cylinder, right? But he hasn't asked this. But if it was the accuracy, then you would have said reliability is just repeating the experiment and comparing. I had a first encounter with such a great mentor in state of shock and relief currently. That's awesome, Abu Bakr. Genuinely saving said pass. Okay, I love you all. Thank you, guys. How much did you get? I got A stars. Okay, read this, yaar. Stop talking. Read this. Ah, too much talking. Hate it, Kim. Love it now. Awesome, Kafia. Sir, you are so underrated. Okay, thanks. I get it. What ranges are available for Pipit? Pipit just measures a fixed volume. You know, it can be 20 cm3, 25 cm3, 25.0, 20.09. There are nano pipettes as well, but in your course, mostly it's going to be 25.0 cm3. Yeah, go to ISL for A levels if you want. It's up to you. It depends. Dekho, A levels, I'm not going anywhere. I'll conduct a proper session for you guys after you're done with your papers. I'll recommend all the schools, whatnot, da 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 da. Yeah. Chemistry is still EU, though only your lectures are interesting. That's awesome, Maheen. Uh, Sir, if I had studied 1 month from you, A star. Okay, read this question. Wait, do you teach at ISL? No, I don't. I don't. I am a solo, not a solo, like I don't work under anybody. Conceptual, this is my academy. I don't work. I'm just saying, the student was saying, should I go to ISL? I was like, oh, it's up to you. You can go if you want. You can go. Nobody's stopping you. Awesome, Iman. Thank you. Thank you. Thank you, guys. Sir, when are you getting married? Hatib, I think our focus should be O levels and IGCSE at this point. Okay. Yeah. But you only need the light when it's burning low. Only miss the sun when it starts to snow. Okay, read. Everybody read. Police, read. Can I eat some chips while you guys read this? Yeah. Hmm. Only hit the sun. Yeah, I have a lot of work, guys. So I have a lot of work pending. So you guys can read this question and I'll solve it. Sir, if you had streamed this onto YouTube, there would have been 10,000 views. I don't care about the views, man. On, do you have a paper? Do it quickly, please. I'm trying my best on. I'm trying. I swear I'm trying. I'm not from Saudi, you know? هم ناقصاني ولا بركة برصاني والشراب الاسكندراني نمتي لما رجال وريها السعادي والقناوي والسيناوي والمحلى واللي ميا ميا والنوب الغمان من وثق سويس الدنيا حفا قدا قدا فلم يا مكاد العدا فلم يا شرع والنوية بعد الأعوى والنوية بعد الأعوى وأعمالنا كبير. No, I'm not Arabic. It's just a song. Yeah. So it's a song. I'm not offending anybody. It's literally a song. Bushret Khair. That's the name. You could search it up. He sings it for Egypt. Yeah. Guys, your time is more precious. I could go on chit chatting, but I think at the end, I'll be fine, huh? Bro, आप ना करो. Okay, Daud, I won't. जानी ना करो. Okay, नहीं करता यार. I won't do it, man. I won't sing. Sir, your Arabic pronunciation is better than me. I've been living in Saudi for 11 years. Ali Hassan, because I used to speak Arabic. أنا أتكلم في اللغة العربية ولكن أنا أتكلم قليلا جدا. لست أكلم. Yeah, I don't speak now. I used to speak. I said I used to speak Arabic back in the day, but then I've forgotten. Now I don't speak proper Arabic. Okay, guys. Hey, let's come back to the class. Let's come back. Let's come. Chop, 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 chop. Some of the students have a paper in the morning. So please chop, chop. A student investigates the reaction between aqueous magnesium sulfate. So if it's aqueous magnesium sulfate, you're going to have the magnesium 2 plus ion and the sulfate 2 minus S. And aqueous barium nitrate. Barium nitrate means you're going to have the barium 2 plus ions and the nitrate 1 minus ions. Done? And he says a precipitate. Now, my question to you guys is if there's a reaction between magnesium sulfate ions and the barium nitrate ions, something's going to happen. If you add both of them to a container, what's going to happen? What's the difference? You'll realize that if you check out the solubilities, you know that magnesium nitrate is soluble, nothing's going to happen. It'll be aqueous. Barium nitrate, aqueous. Barium and magnesium are going to repel each other because they are positive ions. But when the barium ions come into contact with the sulfate ions, you know that barium sulfate is an insoluble salt, and this is going to give me a white precipitate. Make sense? Yeah. So he says a precipitate of barium sulfate forms in the reaction. We already knew that, Dumbo Jumbo. The student does 8 experiments. The student must have the strength to do so many experiments. He's just Vela. That's what we call Vela. Okay, experiment 1. Fill the burette with aqueous magnesium sulfate. Run some of the aqueous magnesium sulfate out of the burette. See, that is a precaution he could ask you. Why is he doing this? To maybe fill the burette jet, or so that the level of the aqueous magnesium sulfate is on the burette scale. Students did not students never used to read this properly, and even teachers. And the examiner asked the question, why did he run some? In the recent papers, you can check it out. The examiner has asked this question multiple times. Why does he run some of the solution out of the burette? So that the solution level is on the burette scale, and also to fill the burette jet, to fill the jet right here, this jet. Da, 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 da. Okay. Now it says fill a second burette with aqueous barium nitrate. Oh, that's kind of an interesting experiment. Okay, you've never seen anything like this, but we are seeing it now. So he has filled one with magnesium sulfate aqueous and one with barium sulfate aqueous. Interesting. Barium nitrate aqueous, sorry. Sulfate is obviously insoluble. Okay, run some of the aqueous barium nitrate out of the burette so that the level of the burette scale. Now add 4 centimeter cube of aqueous 4 cm cube of aqueous magnesium sulfate to the first burette into a 10 from the first burette into a 10 cm cube measuring cylinder. So he took a measuring cylinder 10 cm cube and he added 4 cm cube of magnesium sulfate to it from a burette, right? And then he added 1 cm cube of aqueous barium nitrate from the second burette into the same measuring cylinder. Awesome. So in one 10 centimeter cube measuring cylinder, what do I have? I have 4 cm cube of magnesium sulfate and 1 cm cube of barium nitrate. That's how you need to read this, read the question. Now, my question to you guys is, if I had said add like 11 cm cube, or not even 11, add 7 cm cube from the second burette. Instead of 1 cm cube, I'm saying add 7 cm cube of barium nitrate into the measuring cylinder. What's the problem with that? Adding something, Hani, I'll check it, kiddo. What's the problem with that? What's the problem with adding 7 cm cube instead of 1 cm cube? Yes, the total capacity will overflow. See, that's what I want to ignite. Logical thinking. Because when we read the question, it was 10 cm cube of measuring cylinder. So the measuring cylinder can only hold 10 cm cube. You can't add 7 because it'll be 11 cm cube. It'll overflow. The maximum amount it can hold is what? It's 10 cm cube. Yeah. So these things are pretty logical. Place the stopper in the top of the measuring cylinder and invert the measuring cylinder several times. So the measuring cylinder looks something like this. Stopper is like a bung, like even sometimes you could think about it, think of it as a cork. So here you had 1 cm cube of magnesium sulfate, 1 cm cube of barium nitrate, and he starts shaking it, shaking it, shaking it, shaking it. Why is he shaking it? Basically, he wants to ensure that the barium ions come into contact with the sulfate ions. Yes, the final volume is, we'll look at the final volume, Kafia. But why is he shaking it? See, ask yourself every single time, why is he shaking? Where is it? And invert the measuring cylinder several times. Why is he inverting like this? Inverting to mix the reactants, aka to ensure that the barium ions come into contact, all the barium ions come into contact with all the sulfate ions present and form a precipitate, right? So he's shaking obviously to mix the reactants effectively, to ensure that the barium ions, all of the barium ions come into contact with the sulfate ions, right? Yes, 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 great. And then he says, leave the measuring cylinder to stand for 15 minutes. Why is he letting it stand? Because the precipitate will be all over the place. No, it's not about bubbles. It's about the precipitate being all over the place. So he wants to let it stand so that the precipitate starts to, sit at the bottom. You guys have seen, sometimes you would have seen, you put some small solid particles into, or big particles, or big salt particles into water, into like a cup of water, and then, put your hand and start shaking, try to, cork it and start shaking it. The heavy particles will be everywhere, but if you let it stand, the particles will start to settle down at the bottom, right? So you could measure how much of that has formed. So to let it settle, you've also studied sedimentation, so that the precipitate that forms, so that the PPT that forms, so that the PPT which forms settles at the bottom for you to measure how much of it formed, right? Record the level of precipitate on the measuring cylinder. Now, see, if you did not let it stand, how would you record it on a measuring? It would be all over the place. Aisha, you could use whatever English you want, but be careful with use. You could say it, Aisha, but I never recommend using technical jargons to this extent. Because if the understanding behind that jargon gets wrong, you're done for. And the examiner does not expect such technical jargons from you. But okay, if you write it in bio, then fine. Okay, record the level of precipitate on the measuring cylinder. So I record the precipitate, rinse the measuring cylinder with distilled water. Okay, so he's obviously to remove impurities from experiment one, and prepare for the next upcoming experiments. So repeat the experiments using 1.5 cm cube of aqueous barium nitrate instead of 1. Now that's beautiful. My question to you guys is, he's repeating the experiment and slowly and gradually he's increasing the volume of barium nitrate that he's adding. Now he's adding 1.5 cm cube. My question to all of you guys is that what happens to the magnesium sulfate? Is he mentioning that he's changing it? Is he changing the volume of magnesium sulfate anywhere? No, 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 no. So how much magnesium sulfate should there be? There should be 4 cm cube of magnesium sulfate. Yeah? So 4 cm cube and 1.5. I'll just duplicate this because I don't think he's changing anything else. Duplicate. Oh my God, this guy, he's got the nerve to carry out 8 experiments. That's crazy. Wild. He's Vela. So experiment 2, 1.5. Experiment 3, he's doing it with 2.5 cm cube. And repeat experiment, now he's doing it with 3.0 cm cube. And then he's doing with 3.5 cm cube. Remember, can he go above 10? No, he can't because it'll overflow. Now he's doing 4.5 cm cube. And now he's doing 5.0 cm cube. So he's smart because he knows that if I go, above this, maybe above 10. Yeah. Yeah. 10th's like the limit. Yeah. It's not the standard limit, Shamin. It's because he's using a measuring cylinder of 10 cm cube. Come on, read the question. Yeah. Why not 6? That's up to him. Because 6, then shaking it would have been a little harder. That's why he's okay. Yeah. And he's going till 5.5 as well. So he's going from 5 and then he's also going till 5.5. Right here, 5 and then 5.5. Done, sir. Experiment 8. Okay. Volume of aqueous magnesium sulfate added. Those who don't read the question, they flunk it. They flunk it. And okay, yes, you can draw the graph with a pencil. You know, in the exam it says use an HB pencil to draw graphs, blah blah blah. So please use pencils, don't use pens. These teachers, they misguide you by telling you to use pens, and if you make a single mistake using a pen, then how would you fix that graph? Even in the table you could use an HB pencil. It doesn't make a difference, but it's better to use a pen, you know, on the table. Come on, you know, right? So volume of aqueous magnesium sulfate, it did not change. It was 4.0, 4.0, 4.0, 4.0, 4.0, 4.0, 4.0. He did not change it. But in experiment 1, it was 1.0, then it's 1.5, then it's 2.5, then it's 3.0, then it's 3.5, then it's 4.5, then it's 5.0, and then it's 5.5. Done. What? No, 1, it's 0, sir. What do you mean 1, it's 0? What is 0? You said 4.1. Eh? Say 4.1. I said, oh, sorry, 4.5. I said 4.0, 4.0 and 4.1. How do you remember? Because all of them had a difference of 0.5 except for this one. So 1.5 to 2.5, and then there's a difference 0.5. That's how I remembered. And stop nazarifying me, Ali Afnan. You know, stop giving me evil eye. I'm just kidding. I'm just messing around. Okay. Here, now it says measuring cylinder diagram. So here's the solution and here's the precipitate. Now it says level of precipitate on the measuring cylinder scale. You just have to look at this. So it's 1, 1.1, 1.2. Yeah. So 1.2 here, please tell me, somebody tell me. So it's 1.2 at the start. He's already written it. Then it's love you too, Afnan. Hashtag no homo. 1.8, thank you. 3.0, then 3.6, thank you guys. 4.2, then 4.6, then 4.6, then 4.6. Oh my God, thank you, thank you, thank you. Okay, hold up, hold up. Just by looking at this, I can make a conclusion because I know my moles and stoichiometry. This was a beautiful question, you know. What's something that's unusual here, or what's something that's like yeah, something that's interesting in this experiment. If you realize after experiment, which experiment? After experiment 6, that's the cutoff, right? After experiment 6, you know, this is 4.2, this was an increase in precipitate. But after experiment 6, there's no increase from 6 to 7 or 7 to 8. Why? क्या मसला हो सकता है? What could have been the problem? In order for, yes, thank you. In order for the precipitate to form, you need magnesium sulfate as well as barium nitrate. Now what this guy is doing is he's adding more and more barium nitrate, but the magnesium sulfate remains the same. तो बेचारा कितना ही सहेगा at till you know how much will this magnesium sulfate react? You'll realize that it'll keep on reacting with barium nitrate. If you're adding more barium nitrate, magnesium sulfate is reacting because the sulfate ions are reacting with the barium ions and more precipitate is forming. But after experiment 6, you'll realize that even though I have increased the volume of barium nitrate, I went from 4.5 to 5.0. There's no more change in the precipitate, which means that even though I'm adding this, no more precipitate is being made, which means that magnesium sulfate might have died. Might have finished, obviously. So not might have, it actually has finished, right? So magnesium sulfate, aka the sulfate ions, have finished. Now the sulfate ions become the limiting reactant, right? So what am I gonna say? Is that increasing, if somebody were to ask me to give you the general, you know, trend for this entire experiment, if I increased barium nitrate, I saw that my precipitate was increasing. That's like, you know, generically speaking, I saw this, you know. Why was it increasing? Because now I can infer that the barium nitrate was a limiting reactant. But this was only till experiment 6. After experiment 6, what is happening? What is happening? The barium nitrate would remain probably, right? Why would it remain? Because magnesium sulfate, no more precipitate forms, no more PPT forms, no more PPT forms, no more, yeah? Why does no more PPT forms? Because now magnesium sulfate has become the limiting reactant. It has finished. See, that's how easy it is. That's that's how easy it is. If this kind of my brain can't produce this amount of logic, Shamin is fine. It'll be fine. Chill. Yeah. Travis, chill, man. Chill. Yeah. Initially, barium nitrate was limiting. Initially, barium nitrate was limiting because see, the more you added it, the more precipitate formed, which means you had a lot of magnesium sulfate, which could continuously react with barium nitrate. But this was only till now. My question to you guys is, by how much is barium by in from experiment 6 to 7, by how much is barium? You could say, yeah, all the magnesium sulfate was used up. Yeah, you could say that, Ismail. Chill. You could say that. Now, my question to you guys is, by how much was barium nitrate? Sorry, barium nitrate. By how much was barium nitrate in excess? Yeah, that's where I've got you all by the neck. That's where everybody's saying 0.5 cm cube, 0.5 cm cube. No, sir. No, I can't accurately predict that. Why I? Why I? I'll tell you why I. You can't say 0.5 cm cube because it may have been possible that this was, this is when you added 5.0, you saw no more change, right? But this could have been possible that at 4.6, it might have been limiting. At 4.5111111, it might have been. So it can be anywhere from 4.5 to 5.6. Anywhere from 4.5 to 5.6. Yeah. So you can properly detect it. But do you know how we detect it? You know how we detect it? We use something called extrapolation. So now I'll also teach you how you detect it. Previously, such questions used to be tested, but now they're not tested anymore. But hopefully, I'll teach you how to detect it. It can also be from 3.5 to 4.5. No, it can be from 3.5 to 4.5 because the precipitate is increasing. You went from 4.2 to 4.6, so more barium nitrate was being made. You know, I'll teach you extrapolation. So now you're saying complete a suitable scale on the y-axis and plot the results from experiments 1 point. ये हो सकता है. It can also be 4.5. It's also possible. It can also, somebody is also right. Let's suppose we added 4.4 in it. Maybe even at 4.4, it became 4.6. So it can also have been that. So it's not, it's not possible to detect properly. But you use extrapolation to do that. What's that? The examiner literally will make you make the graph, but he wouldn't give you the concept. I'll give you the concept, don't worry. Just the concept of 0.5 cm cube. I just want to get that. I just want to get that concept across. Okay? It's not 0.5 cm cube because it can be anywhere. This can be a range. Yeah? It's extending the graph. Yes. Now see how the examiner will make you calculate it or determine it through the graph. But again, he's not. I don't think he has tested it here, but he used to test it back in 2015, 2014. So he's not tested it in a long time. But I'll teach you what this graph means because that's what you need to understand. Okay. Now complete a suitable scale on the y-axis and plot the results from experiment 1 to 8 on figure 2.1. Draw two lines of best fit through your points. The first straight line should be for the first 5 experiments and must extend to pass from 0, 0. So one point should be right here at 0, 0. Yeah? I have to extend it till here. The second straight line should be for the last 3 experiments and must be horizontal. So the second 3 line must be horizontal, and the first 3 lines would be just a best fit line. Both would be best fit line, but let's see. Extend the lines so that they cross each other. Now let's talk about it. Extrapolation has been tested in February, March. Oh, then I'm a predictor. I'm a genius. Yeah. Okay, great. So level of precipitate. Now, how do you identify the correct scale for it? It must be a linear scale. You can't say this is 1.5, 2.5. It must be either 1, 2, 3, 4, linear scale, can't be decimals. Okay. Now you'll realize that the highest level of precipitate you are getting, you're going from 1.2 to 4.6. So maybe the maximum you'll go to is still 4.6, right? And if you see your big lines, always talk about these big lines. 1, 2, 3, these darker lines, these bigger boxes, the 10 cm box. Now see how many boxes are there. 1, 2, 3, 4, 5, 6. I have 6 boxes. And if I have 6 boxes and I give them, sorry, one is not this. Sorry, my bad. My bad. That's one box. That's the second box. 1, 2, 3, 4, and that's 5. These are my 5 boxes. And obviously I'll add 0.0 because the precipitate that I was measuring was still 1.2 and 1.8. So I'll add a 0.0 as well here for accuracy's sake. So 0.0, 0.0, 0.0. Now, why did I take one per box? I took one per box because I took why did I take the scale of one? Why did I, take the difference of 1, 2, 3, just a difference of 1, 1, 1? Because my maximum reading is 4.6. And I can cover the entire graph. Remember, you have to cover 75% of the graph. And it's pretty easy to determine. You will realize that chill karo shayan abhi padhane laga hu, chill. So you'll realize you don't need to know the word extrapolation or whatnot, but chill. So you'll realize that you need to cover 75% of the entire graph. It's usually either one, the difference of one between these big boxes. It's either a difference of 1, 2, 4, or 5, or 10, or 100, or 50, or something like that. 25, 10, 50, depending on value. So it's always 1, 2, 4, 5, 1, 2, 4, 5, and then 10, 20, 30, 40, 50, it can be any, right? Depending on the maximum amount that you're going in y-axis. If you take 2 as the first, if you're saying, hey, that's 2, that's 4, that's 6, this isn't covering 75% of graph, because the maximum y-axis you'll go till is probably here or something. So it'll be difficult, right? Okay, now can somebody tell me the first 5 points? Can somebody? Okay, somebody's asking, sir, how do you know how much one small box is? See, that's very easy. Your physics teachers should have taught you this, and even the maths teachers. That between 4 and 3, how many boxes do you have? How many small boxes do you have? I have 10 small boxes. 10 boxes represents a difference of 1 cm cube, right? 10 boxes represents, this is per cm cube. 10 boxes right here represents a difference of 1 cm cube. 4 to 3, that's a difference of 1. So one box would mean how many, what's the difference? X cross multiply 1 over 10. So one box is representing a difference of 0.1 cm cube, the smaller box. हो जाएगी Saim, it'll be uploaded. Okay, great. Now, can somebody tell me the first 5 points, please? Please, somebody tell me the first 5 points. And obviously, always read this. So on the x-axis, you have barium nitrate, and here you have precipitate. Barium nitrate here and precipitate here. So don't tell me magnesium sulfate. Everybody's saying 4.0, 4.0. Magnesium sulfate isn't even on the x-axis. So be careful, yeah? The first 5 points, please. 1.5 and 1 point, oh wait, I'll check it. 1.5 and, sorry, 1 and 1.2, okay. 1, this is 1 and that's 1. This is 1 right here on the x-axis, 1, 1.1, 1.2. So I'll put an x here, and then it's 1, 1.2. Then it is 1.5 and 1.8. Okay, 1.5 and 1 point, this is right here, 1.0 and 2.0. The midpoint is 1.5. So 1.5 and 1.8. So that's 1.5, 1.6, 1.7, 1.8 right here. So it's 2 below. Done? Then it is 2.5 and 3.0. So 2.5 and 3.0 right here. See? 2.5 on the x-axis, 3.0 on the y-axis. Then 3.5 and 4.2. So 3.5 right here in the middle, and 4.1, 4.2. 4.2 right here. Done. Sir, ATP is taking too much time. How will it be possible in 1 hour? It's easily possible. It's taking me time because I have to explain everything in very much detail. It will take you very quickly. It'll take you, no time, as long as practice. Okay. 4.0, you need to quickly read it. 3 and 3.6. Did I miss 3 and 3.6? I missed 3 and 3.6. Are you sure? Okay, so that's 3, 3.5, 3.6 right here. Sounds good? So these are the first 5 points, and it should start from the origin. So I'll make this line of best fit. Line of best fit. Yeah. Right here. It doesn't matter even if it goes outside the box. It doesn't matter. Just make a beautiful line. Then, what are the last 3 lines? Last 3 points. Last 3 points. Anybody? Last 3 points, can somebody help me through it? I don't want 4.6 for the last 3 points. So it's 4 point, at what one? At 4.5? So at 4.5, I get 4.6. Okay. 4.5 is right here in the middle, and it's 4.5, 4.6 right here. Okay. 4.5, that's like, oh my God, my bad. 4.6. Done. And then at 5.0, it's 4.6 again. And then at 6.0, 6.0 or 5.5? 5.5, it is 4.6 again. And that is the horizontal line. Let's just make it a little better. Yeah. That's the horizontal line that he wanted you to make. Fun fact, do you want to know exactly after which point? Do you want to know exactly after which point? You know, do you know want to know exactly after which point no more the barium nitrate? What am I saying? Exactly after the point after which no more magnesium sulfate was available. That's the intersection of these two times. That's called extrapolation. See, he said extend the lines to pass through 0, 0, and they must cut each other. So even though the line is this, we make one horizontal, we make one this, and that's extrapolation, just making sure it goes through 0, 0. So that's here, right here. Check this out. Check this out. Fun fact. So even we were wrong. We said it's going to be above 4.5. Not actually true. This is actually the moment where all of magnesium sulfate was used up. And what is this? This is 3, 3.5, 3.6, 3.7, 3.8. That's 3.8. So it wasn't even 4.5, because realize that this, you went from 4.2 to 4.6. This 4.6 formed at 3.8 cm cube. See, at 3.8 cm cube, you had 4.6. And after 4.6, there's no change. So when I was saying zero point 0.5 cm cube is wrong, I was just to debunk the myth, right? But it's actually somewhere here, 3.8 in this case. Yeah. So a student was right. Some student was saying, sir, can't it be like somewhere here as well? It can be. Yeah. Yeah. Muhammad Junaid was that student. So Muhammad Junaid, you're a genius. Yeah. So it's 3.8 in this case. This logic, you need to know this intersection. See, it's even logical. 4.6, after this point no more was being made, so this is actually that volume. Golly, but the examiner will not ask you this. See, he hasn't been testing this a lot. Use figure 2.1 to deduce the level of precipitate on the measuring cylinder scale when the experiment is repeated using 2.8 cm cube of barium nitrate. So 2.8, that's 2.5, 2.6, 2.7, 2.8 right here. So I'm gonna, and remember, he says show clearly on your, no matter how much, Superman you are or whatever man you are, no matter how much, this is extrapolation thing. Yeah, this is just um, extending the lines. Extrapolation is just extending the lines. Yeah, just like we went from in this straight line and we passed it through the origin and whatnot. Now he wants you to show the working. No matter how much of a Superman you are, please make sure whenever he says show working, and even if he does not say it, draw construction lines. What are construction lines? These dotted lines that I've drawn. What does these dotted line mean? These dotted lines mean that these lines are not a part of your graph, but you've used them to figure out readings from the graph. So these dotted lines, no, you can't make a solid line. Please don't make a solid line. You make construction lines. Solid line, the examiner may think that this is a part of your graph. So these dotted lines tell the examiner or tell any scientist that it's not a part of your graph. This is just, maybe the examiner is not that strict, Ibrahim, in O levels. Don't worry. The examiner may not be that strict. So draw dotted lines. Yeah. Thick dotted lines, whatever dotted lines you want to make. And then, so at 2.8, we have to do it, right? So 2.5, 2.6, 2.7, 2.8, and then that's, use a ruler to make these lines, please. I don't have one, so I'll just try my best to be as accurate as possible. Right here, right here. What is this? This 3, 3.1, 3.2, 3.3, 3.4. That's it. 3.4 makes sense. 3.4. Sir, will he ask to make a curve line? No, remember, uh, sir, you being good doesn't give you the right to torture us. I'm just joking, Anya. Come on. Take a chill pill, relax. I'm sorry. I'm sorry. I'm sorry. Khair. Remember, line of best fit in science, if no teacher has ever told you this, in science, line of best fit can also be a curve or a line. You need to look at it. Can you imagine a curve being formed here? What if the points were something like this? What if the points were something like this? Would you draw, like, how can this be a best fit? How in the world can you draw a best fit line like this? So a best fit line can also be a curve. So even if he says draw a line of best fit, and the point, look at this. I'm moving it. How in the world are these covering, points above and below it, and covering, going through maximum points and covering above and below it? And it's impossible. So even if he says line of best fit, you need to draw a curve in this case, because that's what we mean by a line of best fit in this case. So in science, line of best fit can also mean a curve of best fit. Yes, if you see a curve forming and properly the lines are going. So there's also an anomalous point. Yeah, there can be an anomaly, if the curve looks something, if the curve looks something like this, something like this, and one point is here, that doesn't mean you start making a straight line. Look at this. How in the world can the straight line be a line of best fit? So remember, line of best fit can also be a curve in science. If your science teachers haven't told you this, they've been lying to you. Why does an anomalous point exist? I don't know. It depends on experiment to experiment. Had the student repeats the experiment at 6.5 cm cube of barium nitrate. वैसे, can he repeat the experiment at 6.5 cm cube of barium nitrate? Can he do it? 6.5 cm cube? And yeah, 6.5 cm cube of barium nitrate, he's using that. And he's saying predict the level of precipitate on the measuring cylinder. Yeah, see, he can't repeats the experiment using 6.5 cm cube. Now there are two concepts to it, two logics. See, always devise logics in your brain. Logics in my brain. At 6.5 cm cube, it would obviously be 4.6 because no more, the magnesium sulfate has all been used up. But let's devise logic for how he can use 6.5, right? So what's the prediction? The prediction is that it's 4.6 cm cube. Why? Why is it 4.6 cm cube? Because not magnesium, kiddos. All the magnesium sulfate has reacted. All magnesium sulfate has been used up or reacted, whatever. Slash reacted. Yes. So Samir is saying, sir, you also said, sir, how is this possible? 6.5, the measuring cylinder was holding up to, you had 4.0 cm cube of magnesium sulfate into it. How in the world can you add 6.5 cm cube into it? It can't hold more than 10 cm cube. Let's devise a logic for it. Dekho, always devise logics. Always devise logic. So let's talk about the logic. Yeah. Probably, now I don't know, probably, look, yeah, you can also say magnesium sulfate is limiting, whatever. Now, probably think about it as a student. What is forming? What is something new that's forming here? What is something new that's forming here? A precipitate is forming. Yeah. A precipitate is a solid, so it'll sink at the bottom. It doesn't take up as much space as a liquid, right? Why? Because liquid particles have relatively weaker intermolecular force of attraction. They are farther apart from each other. They occupy a greater volume. Solid particles are tightly packed together. Make sense? Maybe, now this is my assumption, but see, it'll make sense to you, and you should also think like this. Maybe what would have happened is that the student was adding the drops of barium nitrate slowly and gradually. When we was adding drops of barium nitrate slowly and gradually, magnesium sulfate's volume was slowly and gradually reducing, and a solid was being formed. So the volume was being reduced, and the solid took up lesser volume than this, and therefore he could have accommodated more than 10 centimeter cube of barium nitrate, and he could have packed more than 10 cm cube of barium nitrate. Make sense? Sir, itna सोचेंगे paper में? No, you're not going to think like this in the paper unless the question asks you this. So if the question requires this, then you start thinking like this. Like I never thought about it, but since he asked me the question, then I started thinking about this. So it's a very easy paper. Come on, Samir. Stop being a crybaby about it. It's a very easy thing. Sir, can you please tell us a suitable line on a graph means? I literally said, Maheen, a suitable line just means a line of best fit. It's suitable. But although the logic can't add it all ek saath because we have to wait for the precipitate to form first. Yes, Usman, you can. You can say. I was a genius. Kiddo Zohair, I got A stars in chemistries in one. Sir, why 6.4.6? Oh my God, it's 4.6 because realize that magnesium sulfate, this is what we said at the start. You guys are forgetting. Magnesium sulfate got used up here. See, after even though you were adding barium nitrate, there was no change. Come on, chill. See, there's a straight line. No more barium, no more is forming. Magnesium nitrate sulfate was being used up. Yeah, Omer, we just discussed why it wouldn't overflow. One of the possible reasons why it wouldn't overflow. But hey, don't stress your mind so much. Don't stress your mind so much. Khair. Don't put too much stress on your brain. Just slowly and gradually go about things. And review when you watch this recording later on, it'll make sense to you. Sketch on figure 2.1 the graph obtained if all the experiments are repeated using aqueous barium nitrate of half concentration used in experiment 1 to 8. What am I going to do about it? Dekho, if you use half concentration, sir, I love you, hashtag no homo. Yeah, hashtag no homo, Sunny. Thank you. I love you too. See, if you use half concentration, what should happen to the precipitate? Half of the precipitate would form. Obviously, the precipitate would half as well, you know. So if you use half the concentration, half of PPT would form. So you need to make, half of the PPT. But you also need to make sure that, think about it. Now, do you want me to give you the proper, see, you need to know either you just leave this question as it is, or you learn you have the understanding behind it. Because I'm giving you logical understanding. Dekhiye, half of the PPT would form. I know that half is going to be formed, right? So if 4.6 is here, if I had a maximum of 4.6, I'll divide this by 2, I'll go to 2.3, right? So 2.3 is somewhere here, 2.1, 2.2, 2.3, right here. Now, my question to you guys is, now again a question. Will I put a point here? Will I put a point here? Will I put a point here? Where will I make the graph horizontal? After this point, will I make the graph horizontal? After this point, will I make the graph horizontal? After this point, would I make the graph horizontal? After this point, would I make the graph horizontal? After this point, would I make the graph horizontal? After this point, would I make the graph horizontal? Which point? That's the second mark. Teachers, man, I don't know what these teachers were doing. Yeah. How would we know? How would we know? Remember, I taught you guys something. This extrapolation right here. This intersection, sorry. This intersection. At what point was no more barium sulfate being formed? At which point was no more barium sulfate being formed, when you added 3.8 cm cube of barium nitrate, right? Because the only thing I know, I have to go till 2.3, but I don't know the extent. I don't know at how much barium nitrate should I make the graph horizontal, but I know that if it was for a specific concentration, 3.8 cm cube of barium nitrate was required, right? But now you've halved the concentration of barium nitrate. So how much barium nitrate would be required now to make this precipitate, right? To completely, make it double the barium nitrate, double it, right? So at 3.8, if I've halved its strength, double the volume would be used. So 3.8 multiplied by 2. What does that give me? 3.8 multiplied by 2. 7.6, 7 point what? 7.6 cm cube. At 7.6 cm cube, the line would become horizontal, because you halved the concentration dot. You halved the concentration, so now double the volume. Remember in titration, we literally did this so many times in titration, logical. When you halve the concentration, double the amount would be used. So if I've halved the strength of barium nitrate, more of barium nitrate would be required. So where is 7.6? Do we have a 7.6 on the graph to make the graph horizontal? Do we have a 7.6? No, we don't. So what do? We go till 2.1, 2.2, 2.3. We go till 2.3 right here, till the end. और अगर आप मार्किंग स्कीम खोलेंगे तो मार्किंग स्कीम में लिखा होगा कि when you make this graph, sketch a line, to this and don't level it off. Teachers say, oh, they just say, because most of them are just crazy. So, I mean, it's okay. If your brain hurts, that means that your brain has slowly and gradually started to adapt to conceptual understanding. Yeah. So instead of just, because you don't know till which point are you going to go. Didn't get it on why you left it at 6, because there's no 7.6 here. I'll make it horizontal at 7.6, but there's no 7.6. So it's going to go till this would have been, if 7.6 was here, then I'll extend the line till 7.6. I'll go from 0 to 7.6 and then make it horizontal after 7.6. When we are preparing a soluble salt, can we wash it with an organic solvent? Yeah, to much extent, yes. It's half because you're using half the concentration. Half the concentration means half the moles. If concentration was 1 mole per dm cube, now you're using half, 0.5 mole per dm cube. So you've half the moles. So half of the precipitate would form. 1 mole per dm cube means in 1 liter there's 1 mole of barium nitrate. But in 1 liter now there's 0.5 moles only. Suggest why the measuring cylinder is inverted several times before after the barium nitrate is added. Come on, now we have to quickly go over it. To mix the to thoroughly. I don't know the spelling of thoroughly. You could check it. I'm not a good I'm not a good Englishman, you know. So to thoroughly mix the reactants. Why is the cylinder left to stand? We literally looked at it. Why is it left to stand? For the why is it left to stand? So that to allow the precipitate to settle down. Yes, to allow the precipitate to settle down or to fall at the bottom, to fall or to settle at the bottom is gonna be a better, you know, at the bottom. Yeah, Aisha, sure. You could say equilibrate. Sure. Fine. Sir, please, sir, are you from Karachi? No. What do you mean, sir? Explain kar de Mariam. We've been over this at the top at the initial time. To mix the reactants, to thoroughly mix the reactants. Yeah, you could write to mix the reactants, to mix the solution, whatever. Oh, that hurt. Crazy. Why would a curve be made SAF? The volumes of both aqueous solutions are measured using burette. Give a reason why burettes were used rather than a measuring cylinder. Huh? A burette is more accurate. It's pretty easy. A BE is more accurate than an M. No, don't write PPT, please. Fariha, I've been saying this to so many students. Don't write PPT, write precipitate. Don't write PPT, please. If you don't know the spelling of precipitate, it's going to be written at the end of your paper. It was copied from that. And even the spelling doesn't matter as long as you write precipitate. Okay. And saying why are burettes used rather than volumetric pipettes? Because volumetric pipettes are used for a fixed volume. Here you're not measuring a fixed volume. You're not adding a fixed volume. So since pipettes are used for a fixed volume, or why am I writing since? I'll just say a pipette is used for fixed volumes, whereas whereas um, we are adding variable volumes, you know, different volumes, variable volumes, whatever. I'm getting a call. I'll pick it up. I think it's from students, but I'll pick it up. Let's pick it up. Yeah. Hello. Hello. Okay, it was a missed call. Let's. I think some students are. You know, some students are worried. That's okay. I'll. Kiddo, I'm currently. Thank you so much for your kind words. I'm currently in a class. Once I get free, I'll call you right back. Yeah. Okay. Okay. We'll call her right back. Okay, sir. Or probably Reno. It's not prank call there generally. Hadam, question finished. This was a very unique question. But now let's talk about rate of reaction questions. This will come for question number 2 probably. At the end, I will also do planning questions with you guys. I'll also do planning questions. Why do you want to say C and V are inversely proportional? Fine, but don't put physics everywhere. But yeah, could say that. Break, please. I need a break more than you guys. Okay, sir. This is a short question. This is a very short question. And after this, there's a temperature change question. Yeah. I've added all the unique questions, you know, things that were pretty unique. And after this, there's a temperature change questions. I think 2 temperature change questions, and then we're done. Yeah. And then there's planning questions. Planning, I'll go over all planning. Don't worry. Yeah. I'll go over all planning for you. Planning is all about thought process. Give me like 7 minutes break. Sir, what if we do planning tomorrow? I think some students have a class, some students have a paper tomorrow, like tomorrow. How about we do planning tomorrow? Is it possible that we do planning tomorrow? Planning? Said there was one question about solubility. Yeah, there's also one question about solubility, I think. I've added it to planning, I think. See, it's different temperatures. Chalo, planning we'll do tomorrow. Ayan, do you have a paper tomorrow or today, day after tomorrow? But let's finish this, na? Let's finish this. Tomorrow, a lot of students It's so fun to do planning questions, honestly. Yes, that's why, because planning questions are pretty easy. If you have a paper tomorrow and I'm unable to do the planning questions, I want you guys to understand to pick up your yearly papers and just check out question number 4, is read them and then look at the marking scheme. Read them and look at the marking scheme and try to understand what's going on. Right? That's the best way to do it, because these question twos are more technical than question fours. IGCC, there's English tomorrow. No, a lot of group link. Is there a WhatsApp group for link for class? Yes, Wali, there's a WhatsApp group. Somebody can, let me just open the chat. Can somebody share the WhatsApp group with Wali? Yeah. Meeting groups. Yeah. Can somebody share the WhatsApp group? Today was fun. Planning class tomorrow confirmed? Uh, I wish. Inshallah. Chalo. I'll try my best. Like, I will try my best. I promise I'll try, because I have a client to cater to as well, but I'll try my best. Kafiya, for you, I'll try my best. For you. Yeah. I'll try my level best. Kiro, it's no problem. I can call you after I'm done with the class. How about in an hour, right? It's fine. It's absolutely fine. I'm in a class. Let me just call you. It's no issue. I'll call you myself. Okay. And just say the moment I get free from this class, I'll call you. I've gotten more calls as well, so I'll call each and every one of you. Don't worry. Okay. Sir, are you Walter White? No. Honey, I will check the DM, inshallah. Do you want me to check it now? Okay. Let's check the DM. Sir, what's your Instagram? It's at SULLI_KHAN. But please, when you send me, or if you want to follow my chemistry channel, it's at Carboxyl Chem. That's Instagram handles, IG handles. Yeah. And YouTube is just Carboxyl Chem. It's Carboxyl. Okay. Just message that I'm your student. I'll, go over it. Sir, please follow back. Awesome, awesome conversation, promotion. Thank you so much, Anya, for your wholesome messages, and I'll follow you right back. And I will go over this entire idea, yeah, after we are done with the ETP. That's a nice idea, Anya. Like it. We'll go over it. We'll go over it. हो जाएगा. Hair. Should we start doing question number 3? Then we'll take some break after question number 3. It's a unique question. Unique question. Okay, let's talk about this. So, calcium carbonate reacts with dilute hydrochloric acid. A student investigates the rate of this reaction using 3 different concentrations of hydrochloric acid, right? So he wants to find out the rate of reaction using 3 different concs of hydrochloric acid. Loosely fitting cotton wool plug. Why is this loosely fitting? So that the gas can escape. Which gas escapes? Carbon dioxide. And that is the reason why the mass decreases. Mass decreases. Why does the mass decrease? Because carbon dioxide escapes, right? But why do you need to put a cotton wool plug? Why? Why do you need to put a cotton wool? Like, the gas can escape as it is. Even if you did not put a cotton wool plug, the gas could have escaped as it is. Yeah. So not mostly about evaporation, but about, these reactions are, they give out heat. These reactions give out heat, and the liquid can splash out at times. So sometimes what happens is that the liquids can splash out. So to prevent the liquid from splashing out, liquid from splashing out, just like, have you ever seen what's it called, have you guys ever seen I'll share this PDF inshallah in the group, don't worry, Anaya. But have you guys ever seen like lava? Like, have you seen magma? Sorry, magma, not lava, magma. It goes like pop, pop, it splashes out. So this happens in these experiments. Okay. The student adds all of the calcium carbonate in the sample bottle to the dilute hydrochloric acid in E, replaces the sample. So this is the sample bottle. He had calcium monoxide, calcium carbonate, added it, da 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 da. The reaction takes place. Replaces the sample bottle on the balance, records the mass every 30 seconds, right? He's taking equal time intervals. Name the apparatus E. So apparatus E is conical flask. That's called a balance and do da 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 da. So you could also call it an Erlenmeyer flask, but if you mess up that spelling, it's on you. Okay, great. Now, it says carbon dioxide is a gas, a product. Carbon dioxide gas is a product of this reaction. Describe the test used to identify carbon dioxide gas. What's the test? Bubble it. It's saying describe. Don't write lime water test. It says describe. Please remember, description and writing is different. So it says describe. So bubble the gas through lime water. That's description. Through lime water. Yeah. What's the observation? The lime water turns milky. So why does it turn milky? Has anybody thought about it or just rote learnt it? Because lime water is calcium hydroxide, and when it reacts with carbon dioxide, it produces calcium carbonate and water. And this calcium carbonate right here, this calcium carbonate, this beauty, that's basically marble chips, the white solid out of which even Taj Mahal is made. So this is like a white precipitate. That's why it turns cloudy, because this white precipitate is being made. Yeah, this is a free group, guys. You guys can all join. Explain why the mass decreases as the time increasing. Because carbon dioxide escapes the flask. Pretty straightforward. The student uses the measurement of mass as time increases to determine the rate of reaction. State a different measurement. So a measurement of mass, state a different measurement that the student could make as time increases to determine rate of remember, rate of reaction, how do you calculate it? Is the change in amount of reactants or change in amount of products with respect to time. So in this case, what he can do is he can figure out this carbon dioxide leaving, right? And the mass decreases. But he could also figure it out by collecting this carbon dioxide. So he could also collect this gas through maybe like a gas syringe or whatnot, and maybe even over water delivery to some extent. But mostly the better version is just to use a gas syringe, right? That'll give you accurate results mostly. And it's easier. So he could just different measurement. He could take the measurement would be collecting the measurement would be taking the volume of gas, but the way you would do it would be with the help of a gas syringe or whatnot. So the measurement that I would take would be the volume of gas. That's what I would measure. He's saying state, don't explain or describe how you do it, but just state. So the way I do it, if he said state and describe, I'd say, hey, you could measure the volume of gas with respect to time and calculate the rate of. Remember this experiment, everybody has almost done this experiment. If you haven't, this experiment would help you a lot in your ATP question 4 planning. Normally speaking, if you want to change the temperature, if you want to change the surface area, you just use the same experiment as long as a gas is involved again and again and again. And students should do this. क्या हो गया रूम ऐसा chill? Sir is wearing a hair tie. So what about a hair tie? I'm wearing a lot of dagis. Sir, how do we know carbon dioxide gas is present in a flask? Abdul Rahim, because there's this reaction taking place. Oh, nahi, oh, nahi, oh, nahi. In question 4, is diagram necessary? Hey! Oh, okay. Let's just make hosts and co-hosts, right? Yeah. Oh, nahi, oh, nahi, oh, nahi. Oh, nahi, oh, nahi. गलत गलत. देखो, I always say प्यार मोहब्बत दो का है, पढ़ लिख लो मौका है. You guys are going on the wrong track. Your speculations are incorrect. Oh, nahi, oh, nahi, पढ़ लो. Here. In each of the three experiments, the student uses a different concentration of hydrochloric acid. और पढ़ना है कल कल मेरे ख्याल से आप लोगों का पेपर है नॉट माय पेपर टुमारो इट्स ओके आई हैव टू को होस्ट एंड होस्ट आई ओपन दिस फॉर you guys but you guys don't. Khair, in each of the three experiments the student uses a different concentration of hydrochloric acid. All the other variables are kept constant. Yeah, he should keep all the other variable constant, because if you wanted, see, the entire experiment revolved around finding the rate of reaction, right? So if he wants to find out the rate of reaction, he must keep all the other factors constant. What are the factors must be constant? For that, you have to think from the perspective of rate of reactions. What are the factors that affect rate of reaction? Those factors are temperature, maybe even, catalyst. But in this case, he isn't using a catalyst, so I won't go into catalyst. Surface area, you won't say pressure because pressure is only applicable for gases. So pressure is wrong, Omar. Pressure is only applicable. So it's surface area, temperature, or other things that so these are the two things that affect the rate of reaction. Is it a 2 mark question? Yeah, even he has asked two variables, right? But even with these two, you could also keep something else, the mass of calcium carbonate also. The mass of calcium carbonate that you're adding, that should also be constant. Or even the volume of hydrochloric acid that you're adding should be constant. Yeah, so these three things, it's better to just write temperature and surface area. So two variables, which is temperature and surface area, because they're gonna affect. Acha, volume is in excess already. Okay, I'm sorry. If the volume is in excess, then it's fine. Where is it? Where is it written? It's not written. It's not written. Okay, here it doesn't make a difference. Down because the hydrochloric acid is in excess. So fine. So if it's in excess, it's for all three experiments. My bad. So it's these three only. It's this, and this. Yeah, these should be kept covered. Now see, hydrochloric acid concentration 1.5, 0.25. The more the concentration, the higher the concentration, the higher the rate of reaction. So higher concentration means what? Higher. So experiment X would have the highest rate of reaction because it's the most concentration, which means more concentration means more particles per unit volume, which would increase the frequency of collisions. The total successful collisions would increase and the rate of reaction would increase. So this is the highest, then that's the second, that's the third, right? This is double this and 0.25 compared to Z. X is 4 times as high as Z, and X is twice as high for rate of reaction as Y. You know, twice as much. So in experiments, which of these experiment is XYZ? X was the highest, and you realize that this is the steepest gradient, the steepest tangent. So the steeper the tangent, the higher the rate of reaction. So experiment X is, see why? Because when you take the change in y-axis and the change in x-axis, the change in y-axis is going to be more with a steeper line. This is horizontal, flatter, and steeper is more towards vertical. So this is the steepest, and then that's second, that's this. So that's X, that's Y, and that's Z. Describe why the graph is used to, how the graph is used to predict which experiment has the greatest risk. How is it used? The steeper the gradient, or the steeper the curve, no, sorry, the steeper the tangent, or you could even say gradient, the higher the gradient, and therefore the higher the rate of reaction. Write a letter, we've already written it. Describe how the graph shows that the reaction stops, because the graph levels off, all the graphs become horizontal here. So the reaction stops, stop. Yeah. So the reaction stops. Oh, why am I saying the reaction stops? I already know the graph levels off. Yeah. Why am I saying reaction stops? The graph, what am I saying? Levels off. Or it becomes flat. Or whatever, it's the better word for it is leveling off. One more thing, you could have also said that how is the graph used to determine, either by tangent, or you could say that uh, the how would you decide the one that has the greatest risk? The one that levels off the quickest. See, this is leveling off here, this is leveling off here, and then this is leveling off here. So you could have also said that the one that levels off the quickest is gonna have the one that levels off the first is gonna have the greatest rate of reaction. Khair, explain why the reaction stops. Because the reactants are used up. And which reactants? Hydrochloric acid was in excess. He's even written it for you. Where is it written? Somebody told me it's written. Yeah, he's written it right here. So hydrochloric acid in excess. So you can't just say the reactants are used up. See, you have to be very careful. The reactants are not used up. The calcium carbonate, the reactant is used up. So the calcium carbonate is used up. You can't say the reactants is used up, because then the examiner will say, hey, hydrochloric acid isn't used up completely. So read the question carefully. And probably the examiner will also have said the same thing. This is the last question for temperature, and then we'll be done for the day. The second question for temperature, if you want to do, you could do on your own. This is the second question for temperature, but because that's the second question. But I think this one is better. Should I do the first one or the second one? That's up to you. The first one is too lengthy, man. I'll have to read a lot of it. My first, second, the harder one. I don't know which. The both are the same. Literally, both are the same. The graph one. Both have the graph, Samir. Okay, chalo, we'll do this one. The shorter one. We'll do this one, and then we'll do the other one as well. And then see, I think we have a little while. I'll also go over the planning experiments if you want. If you want, I'll go over. Generally, I'll go. No, no, I'll generally just in 15 minutes. In the last 15 minutes, because some of the students have the paper tomorrow. So in the last 15 minutes, is it possible for me to go over quickly? Yes, okay, fine, fine, fine. So, chalo, perfect. In the last 15 minutes, I'll have a detailed class as well, but in the last 15 minutes, I would just wanted the ones who are going to be appearing tomorrow, the Saudi people and the Kuwaiti people, you know, I want them to have an understanding of how to go about question four. Okay, so we'll do one question and then I'll go over question fours. How do you go about them? It's pretty simple, pretty easy. Okay, pretty easy. Saudi paper have variant one. I don't know. Some of the students are just have the paper. I don't know. Some are saying they have a paper. Maybe they're from somewhere else. I don't know. Sir, open the chat. I'll open it. Okay. So solubility one. What solubility one? Dot. English paper is tomorrow. Some students are saying that it's tomorrow for them. Some students are saying that the paper is tomorrow. I don't know. They're probably talking about. Can somebody confirm? Can somebody confirm that the chemistry IGCC paper is not on the 15th? But somewhere. So it's on the 15th. So throughout the world, 15th is not tomorrow. It's day after tomorrow. Chem P4 is on the 15th. So can we have a class tomorrow for the planning questions? Yes, thank you. Why were you guys making so much fuss about it? Oh my God, tomorrow is our paper tomorrow. Some of you guys were lying to me. So we'll have a detailed overview. Sir, many first thank you. Okay. They were talking about IGCC English, I guess. Okay. Break it, chalo, break it. Enjoy till 10:45. Then we'll do the last question. Then we'll do both the questions. Chalo, we'll do both the temperature questions. You know, I always say a teacher is always motivated by a teacher is always motivated by dot will do this. A teacher is always motivated by the students. So the more energetic the students are, the more energetic. Although I am so tired, I'm so tired today. I had to, have I was going over the audit of a new client, and it's just so much work, too much work. Where do you work? I work at PwC, Price Waterhouse Coopers. It is one of the big four accounting firms in the world. In assurance, it's number one in the world. Yes. Chem kaha padhate hain? I don't teach chemistry anywhere except for online because I don't have the time. I travel all the time. How much do you earn? Enough enough if I want to leave. If I don't want to teach, I wouldn't need to teach. So enough. I earn enough, enough to eat twice a day. Sir, I'm a chartered accountant by profession. No? Sir, we all know you are rich. You have 5 cars standing. We've seen the Kala Dalas. Oh, chill, 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 chill. Oh, nahi, oh, nahi, oh, nahi, oh, nahi, oh, nahi. Sir, can you afford chal ho se? Yaar, bade महंगे हो गए. 15,000 per something. It's too expensive nowadays. Hmm. Oh, nahi, oh, nahi. Oh, nahi, oh, nahi. Taimur, stop spreading. Where do I live right now? I live in Islamabad. सर आप खानदानी अमीर हैं हमें पता है नहीं sir isn't life boring living alone it is you guys wanted a break is this how you treat your break Samir love from Islamabad sir lives in a posh farmhouse oh my god kill me do you know Pack College yes I have not studied from Pack though angel I am like an angel mankind's angel. My heart is like a rose, mankind. Yeah. Zoom is saying playing music question marks. You know. सर की शादी करवानी है सर अली ने सर की शादी करवानी है सर अली ने मेरे पिछले सर अली has announced my marriage like 4 times in the previous 4 sessions. Sir Ali lies. I am not getting married anytime soon. Chill. और नहीं हमजा, नहीं और नहीं बच्चे नहीं, फिर मैं आई मेक इट होस्ट एंड को होस्ट अगेन, आई मेक इट होस्ट एंड को होस्ट अगेन इफ यू गाइस यू नो, आई मेक इट होस्ट एंड को होस्ट अगेन, इट्स अप टू यू। तो थोड़ा सा चिल, यू नो, जस्ट रिलैक्स, या ओके, चिल, इट्स फाइन, there's so many messages coming. Make me co-host for no reason, no sir, you have to invite us for shadi, absolutely I will। और नहीं दाऊद, चिल, नहीं और नहीं यार, boys are too immature, yes, you are right, true, that's why I keep it hosts and co-hosts, because I can see all the gibberish that they type in the chat। What about Sir Ali himself? Sir Ali की 10 दफा कह रहा हूँ सर अली की इंशाल्लाह 10 तारीख को होगी, अगले साल 10 तारीख को। अब कौन सी 10 तारीख, आई डोंट नो। हाउस लाइफ इन इस्लामाबाद इज फाइन मारिया। सर आर वी योर फेवरेट बैच? आई डोंट नो, I don't know at this point. All batches are my favorite batch. Sir, I swear to God, I'm sending you this in direct message, but I will make you famous. I am going about telling every teacher about you. All the famous teachers, I am telling them about you. They should know you. You are so underrated. I love you so much. Love from Kuwait. Love you too, man. Thanks. Thanks. कौन सा face wash? I swear I don't use face wash like that. Pakistan. Guys, break means everybody just keeps quiet for the next 5 minutes so that my throat also gets some rest, you know. My throat is getting warmer and warmer and warmer. I think I should do this question. Yeah, it's shorter. This one is lengthy. Yeah, I'll just do this one. This one is shorter. Both are the same though. Both are the same. One just needs reading. Sir, my paper didn't go well. What should I do? Just pray for the best. You said both. I did, but now I don't feel like it because I'm getting tired. My throat is started to hurt, and I'm so hungry. I haven't eaten since morning. I'm sorry. But see, this will cover everything. This entire thing has covered everything except for question number ones, which are just precautions and apparatus identification, or maybe chromatography separation techniques, and question four, which we'll do tomorrow. Question four, I'll do tomorrow. So we'll be done. Tomorrow, same time, sounds good? सर मैंने आपकी जान नहीं छोड़ेंगे, प्लीज फेवरेट पाकिस्तानी डिश बताए। आई लाइक पुलाव, गोश्त, मटन। आई डोंट चिल अली। Okay, it's time to co-host and co-host it 'cause you guys are just like going crazy. I love it. I love it. I love an interactive class, but come on, yeah. You have a paper. My time is not that important at this point. Mutton is overrated. Don't blame me. Ibrahim, you need to eat it in KPK, or you just need to slaughter your own animals and then eat it. Don't buy it from the market because from the market it's not that good. We will cover all possible experiment or only general experiment. No, Daniel, I'll cover the planning experiments in totality. I'll teach you how to think. Dekho, teach a man how to fish, and you would have done him a great favor throughout his life. So I'm not going to teach you how to rote learn questions. You could do that on your own. I'll teach you how to think. Yeah. Minus sir scenes on the na kare. What do you say, man? I mean, go up. There's so many texts coming so quickly. Mahina, there's no message of yours. Mama just made pulao, location drop kare. Ryan, do you live in Islamabad? Can I get some? I've okay. Someday, inshallah. Chalo, kisi din kar lete plan. I need to have if we get more students from Islamabad. Oh, Rania, you're in Lahore. I was first gonna shift to Lahore, but I was like, hey, let's just shift to somewhere. Yeah. All these students are from Lahore, mostly is Lahore. Fatma Singh, I'm from Islamabad. If we get more students from Islamabad, then I'll host a party for them here at my farmhouse. And then I'll invite all of you someday. All of you, all the students that have studied from me, as long as you guys are not, as long as you guys don't kill people or aren't like, something like that, you aren't into that thing. So I invite each and every one of you, inshallah. One day when you guys graduate universities, hopefully. because your parents won't give you permission to come all the way from Karachi or Lahore to Islamabad to visit Sir Suleiman. Yeah. So I hope nobody is a serial killer. I'll invite all of you. Once all your university finishes, then then you'll all be grown ups. Then I'll also love to interact with all of you. Khair. Chalo, let's start this question and then we'll call it a day. I am a chartered accountant, kiddo. I don't go to university or college. I just look young. I work at PwC. I look young. Sir, Peshawar aakar have dinner with us. Thanks, Thania. Would love that someday. My job is physical. That's why I'm in Islamabad. PwC Islamabad office. सर आपने एटीपी की मैक्स तैयार करा दी लव यू बट दिस इज लास्ट ओके a student investigates the temperature change remember when temperature change, that's the last type of question too that could be asked, right? So whenever you talk about temperature change, when he talks about change, there must be an initial reading. He must take an initial reading, he must have a final reading, and temperature change, there should be multiple things clicking in your brain. uh, Multiple things that should click in your brain. Number uno, the first thing that should click in your change is this reaction is either going to be exothermic or endothermic, and you'll figure out whether the temperature is increasing or decreases. If the temperature is increasing, it's exothermic. If it's decreasing, because everything gets hotter in exothermic. So if the temperature is increasing, it's exo, and if the temperature is decreasing, it's endo. That's the first thing that should click. The second thing that should click would be that if you talk about temperature, remember to carry this out in an insulator. Preferably a polystyrene cup. Remember, insulator, there must be an insulator, there must be you could use any insulator, but remember to minimize heat loss, to minimize heat loss or heat gain, depending. Why am I saying heat loss or heat gain? Depending on whether it's endo or exo. So if it's an exothermic reaction, you want to minimize the heat loss to the surroundings. Remember, if it's an exothermic reaction, you want to use an insulator to minimize the heat loss to the surroundings. But if it's an endothermic reaction, you want to minimize the heat gained from the surroundings. So that's if it's an endothermic, you want to minimize the heat gain from the surroundings. So these are both from the perspective of surroundings. And these are a couple of things that should click in your brain, right? So the first thing, it's either going to be endo exo. The second thing, change ke liye I need final and initial, and the third is going to be I need to make sure that it's in an insulator, right? It's an insulator. Done. I use an insulated cup or an insulated beaker or some sort of an insulator. Remember, polystyrene cup is good and all, right? But in the question above, polystyrene cup is good and all, but in this question, here he's saying suggest why is it's the temperature change. It's the same question. I saw this, so that's why I just want to go over it. You guys can do this on your own later on. You can find the marking scheme by just searching this up and finding the marking scheme for it. But he's saying suggest why is it not a good idea for aqueous potassium iodate in a polystyrene cup before it is warmed? Why is it not a good idea to put it in a polystyrene cup before it is warmed? So he's saying basically take a polystyrene cup and warm it in it, right? The problem with that is that the polystyrene cup can also melt, because if you're warming it in a polystyrene cup, there's a possibility that the polystyrene cup melts, So these are some tricks that you need. But generally speaking, we use an insulator, preferably a polystyrene cup, to minimize the heat loss or to minimize the heat gain to minimize heat lost or gained from the surroundings, right? Yes, you are right, Zuhair. It's gonna melt. Polystyrene cup will melt if there's a very high temperature. I'll upload this to YouTube. Mass chill. Okay. So the student does two experiments. Use a 25 cm cube of measuring cylinder to pour 20 cm cube of distilled water. Should he use a pipette here? He just want to measure 25 cm cube. He's not measuring 25.0 cm cube. I think measuring cylinder is fine. But if he were to ever ask, acha, and one more thing, he can't use a pipette because a pipette measures fixed volumes. He can't because he wants to pour 20 cm cube. So a pipette is normally the pipettes that we have in our laboratories, that's 25 cm cubes, right? Khair. So he's gonna pipette he's using a measurement to put 20 cm cube of distilled water in a boiling tube. So in a boiling tube, which is even called a test tube, he's put 20 cm cube of distilled water. Yeah, done. Used a measuring cylinder to do so. Use a thermometer to measure the temperature of distilled water. This is the temperature at T is equal to 0. So he'll measure the initial temperature. See, these are the things that should click. These three things should come in your brain right off the bat when you talk about temperature change. So the initial temperature, he measured it, and that was at time equals 0. He then adds 5 grams of sample of solid P to the distilled water in the boil. See, and this is what he's doing. He wants to find out the temperature change when solid P dissolves in water. So he's going to add it to distilled water in the boiler. At the same time, he starts the stopwatch. So solid P will start to dissolve, and the temperature will either increase, rise, or decrease. Let's see whether it's rising, whether it's endo, or whether it's falling, whether it's exo, right? Here, continually stir the mixture. Continually stir the contents of the boiling tube using the thermometer. Why does he want to stir it? Now, my question. Some of you guys might say to thoroughly mix the reactant together, but one more reason is more appropriate than this. What is that reason? To ensure mixing, but I told you, no, 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 no. To dissolving, mixing is the same thing. Yes, because you want to measure temperature changes, now we talk about to evenly distribute the temperature or the heat, evenly distribute. Remember, to mix it's a-okay to also write to mix to ensure that the solid starts to dissolve, but to also evenly distribute the heat. Remember, temperature, we are interested in temperature. Therefore, I'm interested in evenly distributing heat throughout. Yeah, uniform dispersion of heat and whatnot. Yes, Hamza, that's lovely. Khair, measure the temperature of the mixture in the boiling tube every 20 seconds for 120 seconds. How many readings should he have taken? If he's measuring the temperature every 20 seconds for 120 seconds, so can I do? Hey, I can figure out 120 divided by 20. How many readings should he have taken? 6. 120 divided by 25, 6 readings, but you're actually not right. You're not right. Why is it 6 readings? Why is it just 6? 120 divided by 20 gives you 6, but it's not actually 6. It's going to be more than 6. Why? Because one reading he's taken at 0. At time equals 0, he took one reading. So 6 plus 1, he's going to take 7 readings. Just a fun fact. You don't need to know all of this, but just fun facts. And he would have taken 7 readings. Now he's saying repeat experiment 1 using 10 cm cube of distilled water instead of 20 cm cube. Is he changing the solid P? Is he changing solid P or no? Why 7? Because he took the first reading at time equals 0. So this was the first reading, and then every 20 seconds. So 20, the second reading, 40, the third, 60, 80, 100, 120. That's why. So 6 this and 1 initially. Khair, he's now using 10 cm cube of distilled water instead of 20. Is he changing P? My question to you guys is P changing? See, if you've read the question carefully, it's please. And why is he washing it with distilled water? Probably to remove impurities from experiment 1 and whatnot. But one more thing, guys. To remove impurities. But my brain is pretty quick, and this will come with practice. But if it doesn't come, you'll realize, yes, P is not changing, obviously. P is not changing, he's just shifting. He's using experiment 1, but now he's using 10 cm cube instead of 20. So he's just changing the volume of water being used, right? But my question to you guys is one beautiful question. What was I thinking? He's rinsing the boiling tube with distilled water. Something should pop in your brain. If it's not popping, it's okay. You guys are students. But when you read the question and go back to when you if this concept is tested in the question, you should come back to the reading material and read it carefully. But something is coming. Something is not right. It's not about boiling tube is a test tube. It won't break. It won't break. Itna heat nahi hoga. Dot is right. Dot is saying, yeah, he's washing it with distilled water. My professional skepticism is tingling that he's not drying it. And the entire experiment revolves around water. 20 cm cube, 10 cm cube, water, 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 right? So if he just washes it and does not dry it, would that not mean that there are a few water droplets left? Would that not change the accuracy? That's what I'm thinking. Maybe I'm wrong. Maybe I'm not wrong. But let's see. The volume may be altered. So just think. So he should dry it. He's not written it. Let's see whether he has or not. Complete figure 2.12 by using the thermometer diagrams and calculating the temperature decrease from the temperature 0 seconds. For example, at 60 seconds, temperature decrease. So temperature at 0 seconds minus temperature at 60 seconds. So that's what we need to do, right? Temperature at 0, you just need to calculate the temperature decrease from temperature at 0 seconds, right? So at 0 seconds, the temperature was 24 and the temperature decrease isn't there because that was the initial reading. But here, see, that's 20, 21, 22, 23. But remember, see, you guys might think that the examiners are stupid, right? You guys might think, oh, maybe the examiner made a mistake by putting it in the middle. But you're wrong because you couldn't be more wrong. Since it's 20, that's 21, that's 22, that's 23. The examiner did it on purpose for you to understand that this is not 23 and neither is it 22. It is what? It is 22.5. please, right? So the temperature here is 22.5 degrees Celsius. And since this is 1 dp, 22.5 degrees Celsius, right? And what is the temperature decrease? So you went from 24 degrees Celsius to 22.5 degrees Celsius. So what's the temperature decrease? It is 1.5. Yeah. Again, this is exactly at 20, sorry, at 21, because see, 20 is this. That's 21, 22, 23, 24, 25. So that's 21. Yeah. So that's 21.0. What is the temperature decrease? You guys might think, hey, 22.57 from 22.5 to 21, so it's 1.5. But then again, read the question carefully, Samir. It says, if you want to find out the temperature decrease, you do it from temperature at, here we go, at 0. So 0, see, he even gave you the example. If it's 60, if you want to find 60 seconds, see, he even went here. Not just here, he even went here. That even if you want to find the temperature decrease at 60, you subtract it from the temperature at 0. So these are the tiny mistakes that you need to be careful about, right? So he even gave you the example for you to not be confused. Okay, so 24 minus 21, that's what I'm going to do. So that's 3.0, not 3.0, because this is 1 dp, so 1 dp. Yeah, what is this? This 20.0. Can somebody just help me quickly, write this 20.0? This is 19.5, because see, this is 19, that's 20, and this is right in the middle. This is what is this? 19, exact 19.0, and then what is this? 19.0. So probably the reaction stopped after, or you returned, the reaction stopped probably, because there's no more change in temperature. But let's see, let's talk more about this later. So 24 minus 20, that's 4.0, that's 4.5, that's 4.5. Oh, sorry, no, not 4.5. 24 minus 19, that's 5.0. And this is 24 minus 19, 5.0 again. For experiment 2, so this was for experiment 1, we're done. Now for experiment 2, do this. Experiment 2, the one that he did with how much cm cube? 10 cm cube. Remember, now he's using 10 cm cube instead of 20. In experiment 1, he used 20. Remember this. Yeah. Here. So can somebody write this up? So initially is 23, then 19.5, then 17.0, then 15.0, then 15.0, not 15.0, 15.5. I'm not looking at it. I'm just looking at that. See, this is 15, that's 15, that's 16, that's 17, that's 18, that's 19, that's 20. So this is between 15. So 15.5. Thank you. I'm just looking at the chat. Yeah. That's 14.0, then 13.5, then 13.0. Yeah. And then temperature decrease 3.5. Oh, that's a drop. Then this drop, remember, see, this drop is less than this drop. Okay. I'm starting to, think things. This is what, 6.0, that's 7.5, that's 9.0, 23 minus 14, 23 minus 13.5, 9.5, thinking 8, thinking. And this is 10.0. Yeah. Now, Ali, just hold up a second, please. Sir, yeah. Sir, can this be an error as different temperature in experiment 1 and experiment 2? Probably, maybe. Because this initial temperature was at 23 and this is at 24. If he wants the experiment to be carried out, fairly, these temperatures should have been the same. You're right. You're quite there. You're quite there. Normally. Achha, my question to you guys is, if I look at this, if I look at the conclusion for this, is this an endothermic reaction or is this an exothermic reaction? We are more interested in temperature decrease. You may be right. है देख लेते हैं. Those of you who are saying exo, you guys should take a bottle of Dettol, and because I literally said everything gets cooler in endo and everything gets hotter in exo. Is this being cooled or is this being hot? Is it hot or cool? Temperature is decreasing, everything is becoming cooler. Don't confuse yourself with system, mistem, chhod de system ko. Your teachers have taught you wrong, chhod them. I have explained it in my live classes, but just remember, if things are getting cooler, whatever things are, cooler, endo, hotter, exo. Yeah? Exo means exit of heat. Everything is hotter, So it's an endothermic reaction. What should I be careful for now? If it's an endothermic reaction, I go up. I said that I'll use an insulator. See, he's not mentioned whether he's using an insulator or not, but I'll use an insulator. What should be the reason? To minimize heat loss or to minimize heat gain from the surroundings, to actually ensure that there's no heat gained from the surroundings, right? But because if heat is gained from the surroundings, it would overstate my values. Remember, so see, it's so easy to just think. After I figured out it's endo, I could easily use that. I wanna use an insulator to minimize not heat lost, but to minimize heat gained from the surroundings. Khair. Complete a suitable scale on the y-axis to plot the results of experiment 1 and 2 on figure 2.1. Draw two lines of best fit, both. Achha, and one more thing, everybody. One more thing. The temperature decrease is maximum temperature decrease in experiment 1 is 5.0. Ain't that true? Maximum temperature decrease in experiment 1 is 5.0. And maximum temperature decrease in experiment 2 is 10.0. Yeah. And it's again wrong concept. Heat leaves, won't it become on? No, 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 no. Heat leaves every exothermic, hotter, endothermic, cooler. Stop. Don't think about heat leaves, heat forms. Forget about it at this point, because I've taught that a lot, many times in theory. Forget about it for a hotter, every temperature increases everywhere. Exo, temperature decreases everywhere. Endo, finish. Write it. Rote learn it at this point, because I don't want to go into the detail for it now. Okay. And what you notice is that um, between the two, what is the maximum temperature difference between the two? The maximum temperature between the two is almost twice as much. You know, it's almost twice as much. It's from 5.0 to 10.0. That's the max temperature difference. You know, you don't need to use different keys, different words. You should just, experiment. You could just write EP experiment 1 with 1 and then experiment 2 with 2. Let's draw it, right? So here we have temperature decrease, and on the x-axis we have time. So temperature decrease, what is the maximum temperature decrease that we have? Experiment 1, 2, that's 10. So I have to select a scale that would, go till 10. I have to cover 75% of graph with 10. So if I take 1, 2, 3, 4, 5, 6, if I take a difference of 1 between these boxes, I'll only end up till 6. But I don't need 6. I need what? I need to go till 10. So I'll take 2 difference. 2, 4, 6, 8, 10. Some of you might say, sir, why aren't you going here? I can write 12 here. There's no problem in it. But I'll go till 10. Sir, is this okay? Shouldn't you take 2.5? Wrong. You can't take a non-linear scale. It's always going to be a linear scale, right? And one more thing. It's okay. 10, we're going maximum till 10, and this 10 is going to cover 75% of the graph. So no problem. Don't make it too complicated for this one. It's either 1, 2, 5, 4, or 10, 20, 30, 40. 1, 2, 5, 4, 4, 5, whatever. Can somebody give me the readings, please? At point 0, 0, it's 0, 0. You know, he's saying best fit must start from 0, 0. Label both the lines. He's even saying label both the lines. 0, 0, then can somebody tell me, please? Like this, and on the x-axis, I have time. So time, be careful. Time with temperature decrease. 0 pe 0, 20 pe 1.5. Can somebody tell me like this? 20 pe 1.5. So if this is 1, this is 1.2, 1.4, and 1.5 is right here. 1, 1.2, 4, and 1.5. Sir, how do you know it's 0.2 difference? Because 10 boxes represent 2 cm difference. So, sorry, 2 degree difference. So if you have one box, it would represent x. X is equal to, 2 divided by 10. And that's what? 0.2. That's how I know. So you've covered maximum ATB topics except for planning? Yes. Yeah. Can I just copy this from I think we've done this in the live. Have we done this paper in the live class? I forgot it. Have we done it in the live class? Have we done this paper in the live class? Hold up. Let me just, if we have, then let me just copy this. Let me just pause the recording and copy the graph, because I can't be bothered to draw this graph again. You get the idea. Let me just copy the graph, yeah? So I'm in love with you and chemistry. Oh, nine, Ali. No, no. Hashtag no homo. Wait a second. Yeah, I've resumed the recording. So, this was magic, magically we made this. So remember, see, this is experiment 1, and that's experiment 2. Experiment 1 and experiment 2. And you'll realize, look, the temperature decrease in experiment 1 is lower than in experiment 2. There must be a reason to it. There must be a reason to it, and we'll look into it. Probably because the volume that you used, the distilled water that you used was half the amount. Yeah. So you've made these beautiful graphs, and see, even says lines of best fit. I told you in chemistry, lines can also mean what? Lines can also mean what? Yes, you are right. Dot is right. Heat is being distributed in. I didn't want to say it, but you said it. That's awesome. So yes, heat is in fact being distributed in the water. You're right. खैर बाद में देखते हैं इसको. But my thing, just one thing that you need to keep in mind is that line of best fit can also be a curve. Remember this, line of best fit can also be a curve, as long as, drawing a line here makes no sense, because see, if I drew a line here, how do I make it best fit? Like a straight line. So in chemistry and in science generally, line can also be a curve if it follows the curvature trajectory. So we will be making the best fit curve with a compass? No, with a line. Okay. Now it's saying state whether the energy change in experiment one is endo or exo. Explain your answer. Endo or exo? Endo and exo. Why? It's endothermic. Why? Because the temperature decreases. Everything gets cooler, yeah? Because temperature decreases. And compare the maximum temperature decrease in experiment 1 with the maximum temperature decrease in experiment 2. So the maximum temperature decrease is 5 in experiment 1 and 10 in experiment 2. So it's 5 degrees Celsius in experiment 1 and 10 degrees. See, it's 10 mark question, 2 mark question. So 10 degrees Celsius in experiment 2. And since it's a 2 mark question, I'll also write that experiment 2 is experiment 2 temperature decrease is twice as much. So I'll also, quantify it for him. Done? Shouldn't see, I've told you, please, I don't want to go into the theoretical knowledge of why, because heat is going out, shouldn't in degrees. No. If the thermometer goes down, everything gets cooler, it's endo. For now, rote learn this. I don't care, because I don't want to go into the detail. It's a very minute concept. I don't want to go into explain the internal chemical potential energy of the system and whatnot. I'll teach it to you later on in A levels if your teachers haven't taught you how to, because this is a confusion that remains with students. For now, just know ठंडा exo, मतलब cool exo, hot cool endo, hot exo. Yeah, cool endo, hot exo, cool endo, hot exo. Yeah, cool, everything gets cooler, endo, everything is hotter, exo. Temperature, the thermometer shows a greater temperature, exo. Thermometer shows a lower temperature, endo. It finished. Yeah. From your graph in 2.1, deduce the temperature decrease in experiment 2 after 45 seconds. Show clearly. See, it's a 2 mark question. One to show it and one to write it. So showing it clearly. After what? 45 seconds in experiment 2. So see, this is like 40 and this is 60. Now, how do you know how much 45? See, between 40 and 60, what is the change? That's 20 seconds. Some students might not be able to use, logically, they might not be able to be that good in math. And that's okay, that's fine, because you see the difference. The difference is 20 seconds. 20 seconds represent 10 boxes. So one box means how many seconds? X equals 20 over 10. One box represents 2 seconds. So if this is 40, that's 42, that's 44, and 45. You can't cheat the examiner. Remember, if this is 42, that's 44, the examiner expects you to draw the line between 46 and 44. You can't cheat him. So before sitting for the exam, what topic should you revise? I'll go over this in the end. Yeah. So that's around 6. This is 6.1, 6.2. It's around 6.2. Yeah. So I'll go for 6.2 or 6.4. Sorry, 6.4, because point two is the difference. So 6.2, 6.4. So I'll go for 6. And also shown the working, the dotted lines, the construction lines you do it through trial and error. That's absolutely fine. The average rate of reaction decrease, the average rate of temperature decrease in experiment can be calculated using the equation below. The average rate can be calculated using, so he's saying calculate the average rate of temperature decrease in experiment 1 for 120 seconds. So for 120 seconds, from 0 to 120, right here, let me show you. From 0 to 120, what was the temperature decrease? What was the total temperature decrease? 0 से लेके 120 तक. What was the temperature decrease from 0 to 120? So 0 to 120, what is the temperature decrease? You went from 0 to 5. So the temperature decrease, the change in temperature, you went from, how do you calculate average? Remember, you in mathematics, you also calculate average. You take the change, divide the total distance. If I want to calculate the average speed, what do? You take the total distance over total time. So if I want to calculate average temperature decrease, you take the total temperature decrease, which is 5 degrees Celsius, over total time, which is 120 seconds. And he's even hinted it to you. Total temperature. How do you calculate, Samir? How do you calculate average speed in math? Total temperature, total distance divided by total time. So I'm going to take the total temperature decrease divided by the total time. Yeah. So what am I going to do? 5 degrees Celsius divided by 120 seconds. So 5 divided by 120, what do we get? Why would you add all the temperatures? They're different readings at different times. How do you calculate average speed, Iman? That's just a simple question. How do you calculate average speed? Do you add all the average speeds at a particular time, or just take the total speed divided by the total? So it's total over total. Remember, average is total over total. And he's even guiding you 120 seconds, Skinny. Total over total. So 1 over is 120. What do you get? 0.0417. And what are the units for it? 0.0417. 1 mark literally is for writing the numerator and the denominator. So the numerator, because students, teachers also, they don't even write the units. No students write. But remember, numerator as it is, denominator unit as it is. So degree Celsius over second. So degree Celsius over second. That's it. Now, that's a good question. See, state two possible sources of error in these experiment, possible sources. For each source of error, suggest an improvement which reaches, what's the error? See, improvement is to use a polystyrene cup or an insulator. That's the improvement. But what is the error? We discussed the error. He's not used an insulator, so I'll say, hey, use the insulator, use the insulator and whatnot, or a polystyrene cup. Nobody cares. Polystyrene cup. But what's the error? Remember, not heat loss or gain. It is the heat gained, not lost. Remember, it's endo. Heat is going to be gained from the surroundings. So that's, remember, मैंने शुरू में बताया था कि to determine whether you're going to write heat loss or heat gain, you first of all, to minimize the heat loss or the heat gain, you need to first identify is endo or exo. Yeah? So everything is connected. So the source of error is that there's heat gained, not lost. Heat is gained from surroundings. Yeah? That's the error. And the improvement is user insulator. What can the other improvement be? Yeah, I told you one of the other improvement that I told you. Remember, he did not dry it, so I could say, hey, he did not dry it. So this could overstate the value. There is the error is that there is he did not. The error is that there is water still. This is the error. Error is not the fixation. Error is what is the problem in it. The problem is that there is water in the test tube. That's the error. What's the problem? The problem is water in the test tube. Now what am I? Yeah, you could also see the temperature. The initial temperature is not the same. You could have used that. So source of error. What's the source of error? There is water inside boiling tube already in experiment 2. It's not. And what's the improvement? Dry it. Just try it. And the initial temperature of water should have been the same. That can also be an error. That the initial error. What's the problem? Initial temp of H2O of water isn't the same. But let me tell you guys this one thing is not the same. But you're not calculating, and the improvement could be, he probably use water of same temperature. But one more thing, this is not that relevant in this case. Why is this not that relevant? I'll tell you. Surge strength has fallen to 70. Yeah, because you're not measuring the temperature. You're not measuring the temperature, the temperature, just the temperature. You aren't measuring the temperature. You're measuring the decrease or the decrease. So you're measuring a change. Now, my question to you guys is 7 minus 1. What do you get? 7 minus 1. What do you get? 6. 8 minus 2. What do you get? 6. So if the initial temperature of the water is not the same, this reading would change. You'll still get the same change. So remember, this isn't that relevant here. Parallax error. No, it's not physics, it's just parallax error. Possible. You could write it, well, you could write it, but these are the two possible errors that I saw from the description written. But during the paper, you could write any logical reasoning, to be very honest. But these were the two most logical reasoning that I could come up with. You could write any logical reasoning. You could say, oh, he did not stop the time, but then you'll have to also think about the improvement. He did not record the time properly. But how do you know that he did not record the time? Human reaction error. But how do you know that he made that error? How do you know? But he's saying again, because he's saying possible sources of error, so then you could write it. Possible sources, you could write it. But there are two very blunt and obvious errors in the question. You know? You guys could write measuring cylinder is being used, use a burette. Absolutely. You could write use a burette. Instead of a pipette, you could have used a burette because pipette to, in our course is just 25 cm3. So yes, this can also be an error that, he's using a measuring cylinder. That's an error. Possible. Yes. I said because the possible word. Yes. Yes. You're not going to write the negative sign with somebody saying, sir, do we write the negative sign here? No. Why? Because he's already said temperature decrease. He's already said temperature decrease. I love you all. Thank you so much for the class. Once this video is uploaded onto YouTube, share it with the friends who have not taken it, because I think this was the most comprehensive video for ATP. I think it can't be more comprehensive than this. And planning, inshallah, I'll do planning tomorrow with all of you. But I'll also add the link in the description of this YouTube video will contain the file for this, and it's also present in all the groups. I love you all. Thank you so much. It's time for me to go because I'm also hungry. I'm tired. And see you all tomorrow. I'll try my best to take a class tomorrow for the okay. Bye. Thank you guys. Thank you so much for your love. Thank you. Bye guys. Bye. Ciao.